Alright, so I'm using the same website I was using last time, yesterday. I got through the first little trial that you can interact with, but so now I was trying to dabble in SQL. SQL is another that's a I guess a query language that they use in like data analytics and stuff. Um, you can use it with Tableau. I still don't know much about Tableau, so I'm trying to figure all this stuff out and trying to learn, trying to start somewhere. So the Python was fun, but I figured I'd go ahead and take a run at SQL and see how this is different because obviously they don't do the same thing. So, but here we go. Okay.
Welcome to Learn SQL. Welcome to this comprehensive course on SQL, Structured Query Language. Whether you're interested in working with PostgreSQL, MySQL, SQLite, or any other SQL database, this course will teach you the language you need to master them. Let's build a payment app. In this course, we'll work on the database for a make-believe PayPal clone called CashPal. We'll write queries that interact with users, transactions, payouts, and so on. Assignment. The code to the right is a simple query that selects all the rows and columns from a people table. But there's a problem. The table is called users, not people. Fix the bug by changing people to users in given query.
Okay, so this was super simple. Okay, so this is all it was. It was like this. Select star, and the star means select all from people, and you run it. There's no such table as people. If you go to this next tab, then it shows that the create table users, insert into users. So the table is users, and so you have two people in here. Okay. So the problem is that doesn't match users. And now that I run the code, it pops up the users that it was shown on this one. These are the codes for it. And see, now it has it organized. ID, name, age is admin. And it shows all of that in the correct order that it should be. This is false and true. I guess that gives it a 0 and a 1 instead of saying false and true. I don't know if this works the same as Python with the how you call them, booleans, however you say that word. But anyways, what is it? Okay.
Select single column. Databases are made up of tables, which are made up of fields, aka columns. It's just like an Excel spreadsheet, where table equals sheet, field equals column. Our CashPal users table has this structure. ID, name, age, balance is admin. For example, 1. John Smith, 28, 451. 2. Darren Walker, 27, 200, 1. 3. Jane Morris, 33, 496.24, 0. There can be many records, rows, in this table that each represent a single user, but each row has the same columns. ID integer, name string, age integer, balance float, is admin, boolean, true false. Syntax. In the last lesson, we used the star wildcard to get all the columns. To select a single column, we simply swap out the star for the name of the column. So this becomes this. Assignment. Write a query that selects only the age column from the users table.
Okay, so these are columns. Wait, is this a... That's so confusing. So obviously this whole thing's a table, and then columns are made up of, which are made up of fields, aka columns. I think columns go this way. Many records, rows in this table, and then I think rows are like up and down. I'm not positive on that. The assignment was simple, so if you put or is it star, and run it, then it shows everybody, and it shows everything, right, that you have in this coding right here. If you delete the star and put in a specific single column that you do desire, like name, I wonder if I can put this, names, no. Okay, so I gotta type in name. Then it just shows the name. It just shows all the names. It shows that whole column. Okay. I typed wrong. No, I'm saying that's wrong. Okay, wait a second. I already did this. What am I doing wrong now? Oh, select name from user. What the? What am I doing wrong? Age column from user table. Age. Oh, age, not name. God, what am I doing? Okay, my bad. I said stupid. They didn't want the names. They wanted the ages. Okay, age. Okay, now you see all the ages. Okay. Oops. What? Yes. Okay.
Select multiple columns. As you probably guessed, if you can select all columns with a star, and you can select a single column by name, you can probably also select multiple columns by name. Here's the syntax. For example, if I had a table of monster records for a game, I might write, all SQL statements must end with a semicolon. Assignment. Remember, our users table in CashPal has this schema. ID, name, age, balance, is admin. 1. John Smith, 28, 450, 1. 2. Darren Walker, 27, 200, 1. 3. Jane Morris, 33, 496.24, 0. Update the query to select the age, name, balance, in that order.
Okay, so this does continue from like how Python does things, where it carries stuff over. If you look here, you can put the commas here, and it'll create an ongoing selection that'll also carry on over here. So this 3 goes to ID, this name goes to name, this number goes to age, so on. Like, you're able to create a table from that code. What it was doing here was this originally was shown like this, I believe. It shows everything, but it is wanting you to show everything in a specific order. So instead of showing everything, it wants you to show like this, where you put age, then name, then balance. I don't think I need a comma right there. And then we'll try running that. See, age, name, balance in that order. Everything's, yeah. Yep. Pretty simple stuff. Pretty simple stuff.
What is SQL? Structured Query Language, or SQL, pronounced squeal by the in-crowd, is the primary programming language used to manage and interact with relational databases. SQL can perform operations like creating, updating, reading, and deleting records within a database. Generally speaking, SQL is extremely powerful and programmable. While spreadsheets are great for simple manual data manipulation, SQL is designed for automated and scalable data operations. It can handle large datasets, complex queries, and integrate easily with general-purpose programming languages like Python, TypeScript, and Go.
Yeah, I know that Python and SQL can work together. I don't know exactly how. I don't know. I don't know. I've heard stuff about that. Of course, I'm just entering this, so I have no idea what all this is. But
one day, I catch my manager staring out the window at a guy shoveling garbage off the street and into a truck. He kind of sighed and said, "You know, we're not so different, he and I." And over the years, I've come to understand exactly what my manager meant. As backend developers, we take a bunch of data from one place and shovel it into another place. We're really just kind of moving digital garbage around. That's like the whole job. And the best tool for moving digital garbage is SQL, or SQL, or Squeal.
Squeal.
So say you're a programmer at Google working on YouTube. Your job is to write code that shovels data from creators' devices, so a video, a title, a thumbnail, up into YouTube's cloud servers and stored in some database. Then, when users are bored at their sister's graduation, they log onto YouTube to find a meaningful distraction. Your job is to write code that shovels all that same video data back out of YouTube servers and down onto the user's devices. SQL, or structured query language, is just the language that we as programmers use to communicate with most relational databases. And it's so popular that databases are broadly categorized into SQL databases and no SQL databases, or no SQL databases, which really just means everything else. So what is a database? Well, really, it's just a program, usually separate from your actual backend application server, that's built to store large amounts of data on disk, and importantly, to store it in a way that makes it fast to access, with advanced filtering and sorting options. You can kind of think of it like a programmatically accessed Microsoft Excel. Now, with Excel, you move data around fairly manually by pointing and clicking, typing and dragging and dropping. A relational database works similarly, in that data is organized into tables of rows and columns. But it's all managed in code, not manually with mouse clicks. Your code automates the creates, reads, updates, and deletes within the database. The code that interacts directly with the database is, you guessed it, SQL. SQL is just a query language that we use to get data in and out of relational databases like MySQL, Postgres, or SQLite. It doesn't matter if your backend programming language is Go, Python, or TypeScript. If your database supports SQL, you can use SQL syntax to get data about a user named Bilbo out of your database. Select first name, last name, age from users where email equals bilbo@boot.dev.
So even if you got something written in Python, you can use it to access that information if you're searching for something or organizing something. That's what it sounds like. I'm not positive. Which would you most likely use to keep track of your personal taxes and budget? I originally put a highly scalable SQL database, but it's an Excel and Google spreadsheet. Because, I guess what I was getting confused was SQL isn't what you would actually use, but it's the thing that's running in the background, as Excel and Google Sheets are more visual, so...
What is SQL? Structured Query Language, or SQL, pronounced squeal by the in-crowd, is the primary programming language used to manage and interact with relational databases.
One day, I kept...
SQL
that's the same thing. Okay. Which would you most likely use to store student records for an online school? Would I use this SQL database? Oh, okay. I think I'm starting to understand now. Okay, which database use SQL? SQL is just a query language. You typically use... I don't need to read. I can make him read.
Which databases use SQL? SQL is just a query language. You typically use it to interact with a specific database technology. For example, SQLite, PostgreSQL, MySQL, CockroachDB, Oracle, etc. Although many different databases use the SQL language, most of them will have their own dialects. It's critical to understand that not all databases are created equal. Just because one SQL-compatible database does things a certain way, doesn't mean every SQL-compatible database will follow those exact same patterns. We're using SQLite. In this course, we'll be using SQLite specifically. SQL is great for embedded projects, web browsers, and toy projects. It's lightweight, but has limited functionality compared to the likes of PostgreSQL or MySQL, two of the more common production SQL technologies. We'll point out to you whenever some functionality we're working with is unique to SQLite. Assignment. One way in which SQLite is a bit different is that it stores Boolean values as integers, the integers 0 and 1. 0 equals false, 1 equals true. Select all of the IDs, names, and isAdmin flags from the users table.
Okay, Okay, so it wants me to select ID. Oh. Name is admin. Okay. How to do it from users. Okay, I mean that's pretty simple. I mean, I'm just doing the same thing I did earlier. Yeah, it wasn't hard at all.
NoSQL versus SQL. When talking about SQL databases, we also have to mention the elephant in the room, NoSQL. To put it simply, a NoSQL database is a database that does not use SQL, structured query language. Each NoSQL typically has its own way of writing and executing queries. For example, MongoDB uses MQL, MongoDB query language, and Elasticsearch simply has a JSON API. While most relational databases are fairly similar, NoSQL databases tend to be fairly unique and are used for more niche purposes. Some of the main differences between SQL and NoSQL databases are: NoSQL databases are usually non-relational. SQL databases are usually relational. We'll talk more about what this means later. SQL databases usually have a defined schema. NoSQL databases usually have dynamic schema. SQL databases are table-based. NoSQL databases have a variety of different storage methods, such as document, key-value, graph, wide column, and more. Types of NoSQL databases: document database, key-value store, wide column, graph. A few of the most popular NoSQL databases are MongoDB, Cassandra, CouchDB, DynamoDB, and Elasticsearch.
So you don't have to use a SQL database. There's other databases that do the same thing SQL does, but it's not going to be the same. I got a headache. Need some headache medicine.
SQL isn't web scale. Why don't you use MongoDB? MongoDB is a web scale database. Look, maybe you've heard claims like this before, but let's talk about the real differences between SQL and NoSQL databases and look at some of the more popular technologies in both categories. So on the SQL side, we've got Postgres, big favorite of mine. You've probably also heard of MySQL and SQLite. There's SQL Server, which is Microsoft's product, and I'll also mention CockroachDB, which is a pretty cool distributed SQL database. Now, there are hundreds of SQL-compatible databases out there, but these are probably just some of the ones you've heard of. Now, MongoDB is probably the most well-known example of a NoSQL database. In fact, some people even use the terms synonymously, which I think is a big mistake. You've probably also heard of Redis, maybe Elasticsearch. Firebase is another really popular one. It's more than just a database. It's kind of a backend as a service. And I'll also mention DynamoDB, which is Amazon's big data store. Now, the first thing you need to understand about the difference between a SQL database and a NoSQL database is that SQL databases tend to be much more similar to each other. They're grouped together in this category because they all have something in common. They all use structured query language to be queried. But NoSQL databases, really the only thing that they have in common is that they don't use SQL. So they're all very different, and frankly, they're not even built necessarily to solve the same types of problems. For example, if I asked a candidate in a back-end interview, hey, would you use Postgres or MySQL to build this CRUD app? And they said either would work just fine, that would make sense. But if I asked a candidate if we should use Redis or DynamoDB for our caching layer, and they said, it doesn't really matter, then there's no way they're making it to the next round. Now, SQL databases tend to be more general purpose. Now, that's not always true, but at the end of the day, a SQL database is just a database that supports SQL. So you can have a more specialized SQL database, but most of the popular SQL databases are good for general purpose starting points for web applications. One exception might be SQLite, which is built for small use cases where you want to embed the database directly inside your application. And NoSQL databases, on the other hand, they tend to be very specialized. NoSQL databases are usually built for a specific purpose that a general purpose SQL database doesn't handle as well. Again, one exception is probably MongoDB, which is a fairly general purpose database.
Hey, what's up, man?
It just happens to not
Trying the
exist.
SQL
For
thing out
example,
now.
Redis is mainly used for caching in-memory data for super low latency access. It's common for web apps to use Redis together with a SQL database, and they use Redis as sort of this caching layer. Elasticsearch is another example of a very specifically designed NoSQL database. It's designed for dynamic search and aggregations. It powers things like the eBay search bar. It handles fuzzy text matching and ranking of results. Another one is Firebase, a Google-hosted product. It's really built for real-time mobile apps. And the last one I'll mention again is DynamoDB.
Well, SQL's
It's
different. It's definitely not the same.
Data at scale.
But I thought I'd try it out because I can still interact with it.
Normalize your data, and you can't write the same flexible queries that you would inside a normal SQL database when you use it. The main point here is that an SQL database is any database that you can interact with using SQL syntax, and a NoSQL database is just any database that doesn't have that. When you're deciding which database to use for your application, you really need to weigh the pros and cons for your very specific use case. For most simple CRUD-based web applications, something like Postgres is gonna work just fine. It's a general purpose database that can handle a good amount of scale. But as your application's data grows, or if you have a very niche specific use case, you can introduce other database technologies to your stack at that point.
Mm-hmm.
NoSQL versus SQL. When talking about SQL databases, we also have to mention the elephant in the room, NoSQL.
Oh man, this is the same thing. Should ask another question. Compatible databases tend to be more similar in their functionality than SQL than NoSQL. The SQL databases are similar and non-SQL databases are different. I don't know if this is a lot of coding really, but this is like the backdoor of like, it's not like Python. This is like, it's like organizing stuff.
Comparing SQL databases. Let's dive deeper and talk about some of the popular SQL databases and what makes them different from one another. Some of the most popular SQL databases right now are PostgreSQL, MySQL, Microsoft SQL Server, SQLite, and many others. While all of these databases use SQL, each database defines specific rules, practices, and strategies that separate them from their competitors. SQLite versus PostgreSQL. Personally, SQLite and PostgreSQL are my favorites from the list above. Postgres is a very powerful open source production-ready SQL database. SQLite is a lightweight, embeddable open source database. I usually choose one of these technologies if I'm doing SQL work. SQLite is a serverless database management system that has the ability to run within applications, whereas PostgreSQL uses a client-server model and requires a server to be installed and listening on a network, similar to an HTTP server. See a full comparison here. We use SQLite in this course. In this course, we will be working with SQLite, a lightweight and simple database. For most back-end web servers, PostgreSQL is a more
It's hard to
production-ready
wake
option.
up today,
But
not gonna lie.
SQLite is great for learning and for
I've
small
been up
systems.
since like 6:40,
Assignment.
so.
Let's take a look at how SQLite does not enforce type checking. Notice that within the create table statement, name is defined as a text field. Run the code and take a look at the results. Don't submit yet. On line 3, change the text string Montgomery Burns to the integer 1 and run the code. Notice how even though we defined name as a text field, SQLite allowed us to use an integer.
Oh, man,
Like
how many
Python
times
and
they gotta tell me
JavaScript,
this different
SQLite
stuff?
has a loose type system. You can store any type of data in any field, regardless of how you defined it. Remember, just because you can do something doesn't mean you should. To pass the assignment, submit the code in the altered state, where the record with ID 2 has a name of 1.
So try to run it, and it works, but it's saying with SQL in this course we'll be working with SQLite. A lightweight and simple database from us back and web is a more production-ready option, but SQL is great for learning and for small systems. Let's take a look at SQL. It does not enforce type checking. Notice that within the create table statement, name is defined as a text field. Name is defined as named text. Okay. Run the code. On line 3, change the text string Montgomery Burns to the integer 1. Run the code. Let's see. Notice how even though we define named as a text field, SQLite allows us to use it as an integer like Python and JavaScript. SQLite has a loose type system. You can store any type of data in any field regardless of how you defined it. Remember, just because you can have it doesn't mean you should. Yeah, because I shouldn't be able to use it if I'm telling it that it's not an integer, it's text. To pass the assignment, submit the code in the altered state where the record with ID 2 has a name of 1. I think that's all it's saying. Yeah. No, thanks. I'm trying. Yeah, I don't know. I was gonna try to put some more time into this. I'll have to see you later. I want to try to put as much time into learning this stuff as I can because I'm really interested in this.
Creating a table. To create a new table in a database, use the create table statement followed by the name of the table and the fields you want in the table. Each field name is followed by its data type. We'll get to data types in a minute. It's also acceptable and common to break up the create table statement with some white space like this. Assignment. Let's begin building a table for CashPal database. Create the people table with the following fields: ID, integer; tag, text; name, text; age, integer; balance, integer; is admin. Use integer instead of int before submitting your code. While both types are functionally identical, integer is the full standard compliant keyword. We prefer integer in this course for clarity, consistency, and better portability across SQL dialects. Tip: if you're curious, the pragma table info table name command in the test file returns information about a table and its fields.
Returns information about the table and its field. Okay, so what we'll do is they want to create a table, so create table for people. Oh, wait. And I could do it like this, so it'd be ID needs to be integer, and then tag is going to be a text, going to be an integer. Balance is going to be an integer. Is admin obviously going to be a boolean. All right, and the reason is because ID is a number. Tag would be a text. Not really sure why. I guess because you need, it depends on what the tag looks like. If it has like letters and stuff. Name, obviously a text. Age is an integer because that's a number. Balance, integer because that's a number. And is admin is boolean because it's a yes or no question. SQL logic error near table info syntax error. Oh, I think I messed up. I forgot to put this. But is that my problem? Really? Was that my problem? Did I do it correctly? I don't know if I did that correctly. Oh, I forgot the commas. I'm an idiot. Oh my god, that's so stupid. Wow, I really just did that. Oh my god. I just put that all in there as one big thing. Okay. There we go. Wait. No. Is that right? That doesn't look right either. Or maybe that is right. Let's see your name. Type. I don't think it's supposed to do that. I think these are all of these are supposed to be across here. So I did create table people. I thought I did that right. Is that really how they wanted it? I thought they wanted all this up across the top here. Because now it just looks... Well, I guess that's how they wanted it.
Create table practice. In most relational databases, a single table isn't enough to hold all the data we need. We usually create a table per entity. For example, a social media application might have the following tables: users, posts, comments, likes. Assignment. We need a table that tracks the transactions between our CashPal users. Create the transactions table with the following fields: ID, integer; recipient ID, integer; sender ID, integer; note, text, amount, integer.
Create the transaction table. Oh wait, no. Transaction table. ID. Create the table transactions. But you can create multiple tables. Transaction create syntax error. Why? I mean, but I don't think I'm supposed to do it like that, am I? Yeah, I don't think so. Okay, let's do transaction. dang, keep forgetting the commas. Oh, man. Oh, my God.
Altering tables. We often need to alter our database schema without deleting it and recreating it. Imagine if Twitter deleted its database each time it needed to add a feature. That would be a disaster. Your account and all your tweets would be wiped out on a daily basis. Instead, we can use the alter table statement to make changes in place without deleting any data. Alter table. With SQLite, an alter table statement allows you to rename a table or column, add or drop a column. Unlike some SQL databases, SQLite does not support adding multiple columns in a single alter table statement. Each column must be added in a separate alter table command. Assignment. We need to make some changes to the people table. At the moment, we have these 6 columns, shown as rows, so we can display data types. CID, name, type, not null, DFLT value, PK. 0 ID integer, 0, 0. 1 tag text, 0, 0. 2 name text, 0, 0. 3 age integer, 0, 0. 4 balance integer, 0, 0. 5 is...
Okay, so it's already got the people table that it's talking about. Okay. So we're going to alter. I don't know if these have to alter table. The people table. All right. And then let's try. What does it want to rename it to? Rename it to users. Okay. And then rename tag column to username. So we'll do reline column tag to username. And then, oh, you know what? This doesn't work if it's at the end, right? So maybe I can do something like this. I wonder if I can actually do this. Delete the last part. Let's go ahead and put this here. I wonder if it works like this. I don't know. Okay, rename column tag to username. Add password tags. So then I need to add column. Syntax error. Okay, so it doesn't work like that. Does it work like that? Nope. Okay, let's try this. Syntax error. Rename alter table. The table is called people. Alter table. What does it say where the table's called? Okay. I think I did. I think I forgot to put that thing in there. Okay, let's try this again. Rename do it every time? I guess I do. Okay. Alter table users. I have to do it separately every time. So we can do all that. Oh, it says it right here. I'm an idiot. Unlike some SQL databases, SQLite does not support adding multiple columns in a single alter table statement. Each column must be added in a separate alter table command. Huh. Shows me for not reading. Okay, so I renamed add column password as a text, okay, and then I rename it to users, and then rename column tag to username. And tags the second. Yep. Got it. That's kind of fun. Kind of interesting.
Intro to migrations. A database migration is a change to the structure of a relational database. You can think of it like a commit in Git, but for your database schema. Every migration records how the structure of your data evolves over time. For example, when we previously used an alter table statement to add a new column, we were performing a migration. Migrations are essential for adapting your database to changing requirements, fixing mistakes, and rolling out new features. In a team setting, migrations ensure everyone applies the same changes in the same order. Good migrations are small, incremental, and ideally reversible changes to a database. As you can imagine, when working with large databases, making changes can be scary. We have to be careful when writing database migrations so that we don't break any systems that depend on the old database schema. Example of a bad migration. Let's say the CashPal backend runs this SQL regularly. If we rename the table from people to users in a migration, but forget to update the code, this query will break because the people table no longer exists. The right approach: deploy the migration to rename the table. Immediately deploy new code that uses a new query. Migrations must be carefully coordinated with application changes to avoid outages.
Database migrations are kind of like unit tests. Most people suck at writing them, but they do like to talk about how important they are. Now, you're probably doing migrations wrong, or more likely you're not even doing them. So let's talk about the right way to do them. Say that we have a users table with ID, username, and password columns. The database is currently being used in production, and now it's time to add a new feature, and that feature requires a birthday column for each user. The right way to do this isn't to just connect to the production DB with PSQL and run a quick add column query. The right way is to create a migration file. That add column query goes inside it, and our system should be configured to run our migrations whenever we deploy new code changes. Now, when we want to create a copy of the database, or we need to spin up a new local development environment, we can just run all of our migrations one after the other, and the schema, tables, columns, indexes, that kind of stuff, will always match. Now, this type of migration, where we're just adding a new column or a new table, tends to be really safe. None of the currently running queries in production are going to care about this birthday column, so when we add it, those queries will still work. They'll just ignore the new column. See, a good migration needs to think about two things. One, the old, currently running version of the code, and two, the new version of the code that will run after the migration is complete. A lot of developers forget about the old version. They write a migration, they test their new code on the new schema, and then they just deploy it. But as the migration deploys, the app breaks for the couple of minutes when the old version is still running, but with the new schema. So for example, say we create a migration that removes a password column and adds a Google ID column. Maybe we're no longer storing user passwords because we only support sign in with Google. Now, if we run this migration, but the currently running version of the app runs a select password from users query, then user logins are going to be broken until the new version of the code that doesn't use that field is deployed. So you might think, well, great, let's just deploy the code first. But that doesn't work either because the new code depends on the new Google ID column that's in the migration. So the answer here is to do a multi-phased rollout. Step one, we run a migration that adds the new Google ID column, and this is safe. Step two, we deploy the new code that uses the Google ID column, but not the password column. Step three, we run a cleanup migration that just removes that unused password column. Okay, so creating and removing columns and tables is pretty straightforward, but what if we want to update an existing column? Well, generally speaking, the safest thing is to just not do that. At least not directly. It's okay to add an index to an existing column for performance reasons, because that won't break any of the currently running queries. But what you don't want to do is rename an existing column that's being actively used in production. Instead, we should do another more complicated multi-phase rollout. Step one, run a migration to create the new column. Step two, copy the data over from the old column into the new column. Step three, deploy the code that uses the new column, but not the old one. And step four, this is very important, recopy the data from the old column to the new column to catch anything that was missed between the initial copy and the code deployment. And then step five, just run a migration to remove the old column. Now, to be fair, this is kind of a lot of work. If your team just doesn't have the resources to do that, a cheat some companies will use when the migration gets really, really hairy is just to schedule some downtime. You can literally just turn off your application and tell your customers, hey, the whole site's gonna be down for the next 30 minutes while we do a big update to our database. I wanna be clear, this should only be a last resort, and you should only do it if the migration's super hairy and you feel like the time trade-off isn't worth it. Most good engineering organizations tend to avoid downtime at all costs.
Which of the following statements about migrations is false? It can be fast and loose when writing migrations. A bad migration is easy to fix. Well-written migrations are reversible. Migrations are incremental changes made to a database. A good migration takes into account any systems that rely on existing. I think it's I was wrong. Migrations are incremental changes into a database. Maybe this one. I was wrong again. Holy crap. Well-written migrations are reversible. Nope, it's the top one. You can be fast and loose when writing migrations. A bad migration is easy to fix. That doesn't... Oh. It says which one is false. Keywords. False. Oops. Okay. Feed out. Oreo. you poop. Poop paper. I'll bring you poop. That's not what I meant to say. I swear. Let's see. Love you too. There. That works. It doesn't even fit on the line. It doesn't matter. Oh. Here, I'll just center it to screen. Not screen. It's fine. It's fine. I'll delete it later. Oh, and I gotta take toilet paper. I got a house full of kids, so it's a challenge. It's a challenge. All right, back to where we were. Where were we? Where were we? Okay.
Up migration.
You know what? Maybe it'll help if I open this up a little bit. I need some more light up in here. There, get some daylight, some sun. A little flowing in here, help wake me up. Yeah, that's better. That's better. Whew. All right. Oh, that's kind of bright now. Oh. That's very bright. All right.
To manage migrations, we use a simple system based on up and down directions. The up migration applies changes to move your schema forward. The down migration rolls those changes back to the previous state. This allows developers to safely move between versions of the schema during development and production rollouts. Let's write an up migration to add new features to our database. Assignment: add additional columns to the transactions table. We want to know whether or not the transaction was successfully completed between two users. We also want our database to track the type of transaction. Our transactions table looks like this at the moment. CID, name type, not null, DFLT value. PK, 0 ID.
You don't gotta read all that. Complete the following migration in this order. Add Boolean was successful column to the transaction table. Add the text transaction. Bool is valid, but the assignment expects Boolean, so use Boolean instead of bool to pass the assignment. Okay, hold up. We have a table called transactions. Okay. Now that's just to print it out. Alright. It wants me... Okay, so this... What if I run it? Okay, so that's the table that it already has. And... I'm still... Manage migration. Okay, to manage migrations, we use a simple system based on up and down directions. The up migration applies changes to move your schema forward. This allows developers to safely move between versions. Okay, complete the following up migration in this order. A little confused. Okay, so what was it? But if I make a migration, I have what was that freaking thing I had to put to make a migration? Alter table. Okay, I believe I have to use the alter table thing. Maybe. I might be wrong. Alter table. And transactions. Oh. Actions. Add column. Oh, my bad. Wait. Add the Boolean was successful column. What? Table looks like this at the moment. Boolean was successful. What are you talking about? You want to add a column What's successful Boolean? Oh, I get it now. Because Boolean's like yes or no. Okay, so you want to put like was successful, and it's gonna be Boolean, and then alter table transactions, and we're gonna add, I don't know if it matters, but column. Transaction. I don't know if it was S. Type to the transaction table, and it's gonna be a text. Okay. Was successful Boolean transaction type text. Okay, I think that's all it was asking me to do. Yep. That's simple enough.
Down migration.
Down migration.
The migration we applied ended up causing trouble in production. It's possible the app would...
I want to play Rocket League, but I'm trying to focus in on this for a minute. I'm thinking about going through with the full course. I don't know. I'm thinking about it because I really want to learn the Python stuff, but the SQL stuff is good for like if you want to be a data analyst. But then I also have to learn how to use Tableau and Excel, which I mean, I used Excel when I was in high school. That's why I don't understand why Excel is such a big deal now. Because I remember in high school we used all those Microsoft programs. We used Excel. We used Excel a lot. We used PowerPoint a lot. I mean, obviously everybody used Word, but I mean that wasn't like a. I don't know. Microsoft Excel isn't like it wasn't that big of a deal. Like I remember how we made it to where certain like tables would add to other tables and stuff, but I don't know. I don't understand why that's like. I thought everybody knew how to use Microsoft Excel. I don't know if there's something I'm missing. Like I haven't seen it in a while, and like it's changed and it's got more complicating. But like this definitely seems like more work than using Microsoft Excel. Let's see.
wasn't ready for the new columns. In situations like this, we need to roll back the changes safely using a down migration. Why down migrations matter? Down migrations allow us to undo changes introduced by an up migration, quickly recover from bugs or compatibility issues in production, and keep our schema consistent across environments, local, staging, production. A well-written down migration should completely reverse the changes made in the up migration. In our case, that means removing the 2 columns we added. Assignment. Complete the following down migration. Drop the was successful column from the transactions table. Drop the transaction type column from the transactions table. This will revert the schema back to the original state.
Drop it. Hold on. Oh, it's right here. How do you drop it, though? You don't just delete it. You have to add another code to undo it.
Okay, so you think you're a responsible developer because you write well-documented migrations for your database schema. But what happens when one of your migrations is bad? Normal database migrations, the ones that you run to get your database into the correct state for your application, those are called up migrations. They take your database from the old, out-of-date state into the new, proper working state. Now, to be fair, a lot of engineering organizations get away just fine without writing down migrations at all. They just move forward, and in the event of something going wrong with an up migration, they just roll out another up migration that fixes it. And this really can work, especially if you're on a small team. But as team size and application complexity grows, you usually want some more safeguards in place. In particular, you probably want the ability to roll back a change when something goes wrong. Now, it's always easy to roll back code changes. Just go back to the last git commit and deploy that version. But databases are a little trickier. Say you deploy code that doesn't need a bio column anymore. So you run an up migration that drops that column. Then 10 minutes later, you realize there's a bug in the code. So you need to go back to the old version of the application that requires that bio column. You can't just revert the code anymore, because now it's gonna break because the bio column is gone. So that's where down migrations come in. The idea is that each time you write an up migration, you also write a down migration that can be used to undo it. So if the up migration removes a bio column, the associated down migration re-adds it. If an up migration creates a notifications table, then its down migration removes it. The down migration should always be the inverse of the up migration. And it's really only used in the case of failure or a rollback. Now, it's very important to remember that while down migrations can fix the schema of a database so that the code will work, they usually aren't written in a way that will actually recover the lost data. In other words, we can add that bio column back, but all those user bios aren't gonna be there anymore. They're just gonna be blank. So the code will still work in the sense that the queries aren't gonna throw errors, but the data won't be there. So to solve those problems, you need a backup strategy that you can go pull that old data from, but that's another topic.
But how do you type out a down migration? I mean, but you have to write it out, right? Like alter table transactions drop was successful. Okay, that'll probably work. Alter transaction type. Okay, did it drop it? So you add a code to get rid of something, so you don't. Okay, it drops. Okay. Yeah, that worked. It was pretty simple. Pretty simple. It's not very complicated.
Migration review. Let's look at a more realistic migration that reflects a common evolution. Example, the projects table is being renamed to initiatives to better reflect how teams plan and track long-term work. We also want to record when each initiative officially launched. Up migration, down migration. This pair of migrations is reversible and safe.
Okay, wait. The projects table is being renamed to initiatives to better reflect how teams. I also want to record when each initiative officially launched. Okay, so alter table projects renamed to initiatives. Alter table initiatives, add column launched, add timestamp. Okay. And then down migration would be alter table initiatives, drop column launched at. Okay, so wait. Hold on. You can put this in one thing like this? You don't have to like double it up? I don't have to put it. I could have been doing it like this the whole time? Oh my god. Okay. Whatever. Alter tables initiative, drop column launched at. And then all the tables initiatives renamed to projects, so that puts it back to projects. Okay, so that's a down migration. Okay, so you add a code to get rid. You're just adding a code to get rid of something. You never like go back and just delete a code or anything. Okay.
If something breaks, we can undo it. Real-world migration tools. In real-world projects, we don't run raw SQL migrations. We use tools that help track which migrations have been applied, organize migrations in files, apply and roll back safely. Popular tools, tool language notes, Goose Go native Go tool, Flyway, Java, etc. Simple file-based, Liquid-based Java, more config-heavy, Alembic, Python for SQL Alchemy. Prisma Migrate, Node.js, works with Prisma ORM. Example workflow with a tool. This will vary according to the tool you use. Write migration files. 001, add columns to transactions.up.sql. 001, add columns to transactions.down.sql. Apply them using a CLI. Your tool logs which migrations ran and prevents duplicate migrations. Version control for your schema. Migration files are committed like code.
Hold up. Okay, so popular tools, example workflow. This will vary according to the tool you use to write migration files.
They travel with your project, so your teammates and CI systems always apply the same schema changes in the right order.
What are good migrations written in a reversible manner? So that if something goes wrong, the changes can be rolled back. Yeah. Will database migrations often be coupled with application code updates? I would think so. Yeah. That's what I thought. Okay.
SQL data types. SQL as a language can support many different data types. However, the data types that your database management system supports will vary depending on the specific database you're using. SQLite only supports the most basic types, and we're using SQLite in this course. SQLite data types. Let's go over the data types supported by SQLite and how they are stored. Null, null value. Integer, a signed integer stored in 0, 1, 2, 3, 4, 6, or 8 bytes. Real, floating point value stored as a 64-bit REEE floating point number. Text, text string stored using database encoding such as UTF-8. Blob, short for binary large object, and typically used for images, audio, or other multimedia. Boolean. Boolean values are written in SQLite queries as true or false, but are recorded as 1 or 0. Boolean values. It's important to note, SQLite does not have a separate Boolean storage class. Instead, Boolean values are stored as integers. 0 equals false, 1 equals true. It's not actually all that weird. Boolean values are just binary bits after all. SQLite will still let you write your queries using Boolean expressions and true-false keywords, but it will convert the Booleans to integers under the hood.
How is a true Boolean value stored? All SQL databases support the same data types. No. What type would you use to store a user's email? I mean, text? Wouldn't it be text? Well, no, you can. I mean, I think you can, right? Or is it real? What's real? Floating point value stores. It's not a blob. I'm gonna go and put text. Yeah, okay.
Posts table. You're working on CashPal's latest social media feature named CashPal Chatter, which aims to revolutionize financial discussions online. Users can make a typical social media post that contains a picture of their latest purchase, along with text and some other information. You've been assigned to create the new Posts table. Assignment. Write an SQL statement to create a new table named Posts, which should contain the following columns: ID, image URL, description, author ID, is sponsored. Use data types that make the most sense given the column name. For ID columns, assume we can just use integer.
post table writes an SQL statement to create a new table named post. Post, which would contain the following columns. Use data types that make the most sense given the column name. For ID columns, we'll assume you just use integer. Okay. So ID. Image URL was what they call that? It's not Boolean. It's I was blob. Okay. And then description would it be text or would it be that other one? I'm gonna go with text. Okay. Author ID. I don't know. Maybe. I don't know. Is sponsored. Oh, that's definitely Boolean. Okay. I don't know. Maybe. Oh, wait. Oh, whoa. God dang freaking column. Nope. Okay. So, description, author ID. Let's try putting author ID is instead of this, probably integer. And no. Table post. See. Integer null represents a null value. A signed integer can be used. Blob. Better images used for multimedia like images and audio. That'd be image URL. Unless it's not. If it's an image URL, then would it be text? Oh, well, I mean, image URL does make sense that it would be text because it's not a physical image. It's, whatever. This is so stupid. Okay. Alright, let's see what you did there. Do you have another channel or SMTH like that? I don't know what something like that. So I do have another channel, but it's just one that I do with my kids. That's the other PC Tart one. But we haven't done it in a while since the kids are back in school. But it's at like the bottom of this channel. Because I started doing this channel for my boring stuff where it's just me. And then I have the other channel for me and the kids. Whenever the kids want to, like, they like playing like Garden of Band and stuff. But that's the only other one I got.
Posts table migration. CashPal Chatter is a huge hit. After several weeks of use, the engineers at CashPal have decided that some changes need to be made to our posts table. You've been asked to write an up migration to alter the table. Assignment: write an up migration for the posts table that achieves the following. The author ID column should be renamed to poster ID. Add a new column named isEdited with a Boolean type. Drop the isSponsored column.
Dude, this is kind of easy. I don't know if this gets more complicated later on, but this doesn't seem very hard. Alter table. Oh, what's the table? Post. Edited. Drop column is sponsored. Okay. I keep forgetting to put these. Oh, I put C sponsored instead of is sponsored. Is sponsored. I'm typing too fast. Hold on. Okay. That's it. Alter table post. I name author ID to poster ID. Add column is edited as a boolean. Alter table post. Drop column is sponsored. And is sponsored's gone. Cool. This is like pretty easy. I don't know. Null values. I'm assuming null values are known as none in like Python.
Null values. In SQL, a cell with a null value indicates that the value is missing. A null value is very different from a zero value. Constraints. When creating a table, we can define whether or not a field can or cannot be null, and that's a kind of constraint. We will cover constraints in more detail soon. For now, let's focus on null values. Assignment. We didn't force any constraints on our tables when we created them, and it is allowed for null entries to make their way into our table. Let's take a look at our transactions table to see what those null values look like. Write a query to select all of the fields on all records of the transactions table. Tip: use the star wildcard syntax to select all fields. Observe. Notice that both the transaction type and was successful fields have null values in all three records in the table. Nulls are represented by blank cells in our system. That's because we ran our migration in the previous exercise after the three records were created.
Okay, we didn't force any constraints on our table when we created them, and it allows for no. Let's take a look at our transactions table and see what those like. Select. Oh, no. Write a query to select all the fields of the records in the transaction table. Okay. Notice that both the transaction type and have no values in those table. Man, what? Alright. Whoa, whoa, whoa. Or multi-fill. You know, that's kind of the... We don't have force and constraints on our table when we created them, and it has allowed for null entries to make. Select all fields of the What am I doing wrong? Assignment. We didn't enforce any constraints on our tables when we created them, and it has allowed for null entries to make their way to our table. Let's take a look at our transaction tables and see what null value looks like. Write a query to select all the fields. Oh my god, right? To select all the fields on all records of the transaction table. I don't know. Select statement, select ID, select. Oh, am I doing the select? Oh, do I not even need to put table? I think I'm just putting this wrong. Network error, that's when the fish research code execution cancel. Oh, there it goes. Jesus. I was writing it wrong. Okay. Select transactions. Okay. And then it says, notice how both transaction type and was successful are completely blank. Was that it? Correct. Okay. Ah, that was rough until I forgot how to do that earlier. Thought I was typing it wrong. I didn't want to go back and look. It's going to be like yesterday. I'll always be in the show. I appreciate that. It's all good, man. I figured if I'm doing something on the computer, I might as well stream it. Hey, you never know. Like, I don't know. The way I see it is like, I mean, I get on YouTube and I look up a lot of stuff and I try to see if anybody else has like tried to do certain things, and there's not a lot of information on this website in particular, so I figured I'd try it out and see what I can do with it. I've always wanted to learn this stuff. I've always wanted to get into it, so I'm gonna see what I can do with it. I'm considering going through the full course. I don't know, because money's not free, but if it's worth it, nobody knows much about this stuff, so I guess I'm just trying to figure it out. A constraint is okay.
Constraints. A constraint is a rule we create on a database that enforces some specific behavior. For example, setting a not null constraint on a column ensures that the column will not accept null values. If we try to insert a null value into a column with the not null constraint, the insert will fail with an error message. Constraints are extremely useful when we need to ensure that certain kinds of data exist within our database.
Oh, that's like whenever you're entering information in something, like an application or something, and it has that red star next to it because you have to fill it out, and if you don't fill it out, it won't let you continue to the next page. Yeah, and so how do they type that out though? Is there ID integer primary key? Primary key constraint unique. Okay,
Defining a not null constraint. The not null constraint can be added directly to the create table statement. SQLite limitation. In other dialects of SQL,
oh. Let's create table employees, ID integer primary key. The primary key constraint uniquely identifies each row in the table. Name, text, unique. The unique constraint ensures that no two rows can have the same value in the name column. Title text, not null. The not null constraint ensures that the title column cannot have null values. Okay, so there's actually defining a not null constraint. So you can put primary key, ID. The primary key constraint uniquely identifies each row in the table. Identifies each row in the table. Okay. Name text. The unique constraint ensures that no two rows can have the same value in the name column. Unique. Oh, that's like when you're creating a profile ID and you can't have the same profile ID as someone else. You use that unique. Primary key, though, the primary key constraint uniquely identifies each row on the table. I think that's to ensure that you only get the information that you're looking for. In other dialects, okay.
You can add constraint within an alter table statement. SQLite does not support this feature, so when we create our tables, we need to make sure we specify all the constraints we want. Here's a list of SQL features SQLite does not implement, in case you're curious. Assignment. Thankfully, all the tables we have created for CashPal up to this point have been for testing purposes. Now that we have a better understanding of constraints, let's rebuild our database with the proper constraints and tables. Create the users table with the following fields and constraints. ID, integer, primary key. Name, text, not known. Age, integer, not known.
Oh, this is easy. Create table. Users. ID. Trying to remember what the comma's at. Age, integer, country code, text, unique, multiple codes. I don't know if I actually need these commas here or not. I guess I'll find out here in a second. Okay. Username. No. Boolean. Oh, that was it. Yeah, I don't need to put commas there. I can just list them out. Okay. That's easy.
Primary keys. A key defines and protects relationships between tables. A primary key is a special column that uniquely identifies records within a table. Each table can have one and only one primary key. Your primary key will almost always be the ID column. It's very common to have a column named ID on each table in a database, and that ID is the primary key for that table. No two rows in that table can share an ID. A primary key constraint can be explicitly specified on a column to ensure uniqueness. rejecting any inserts where you attempt to create a duplicate ID. Assignment. Run the code. Notice that there's a bug. There is a violation of a primary key constraint on the ID column. Fix the data that's being inserted. When working with integer IDs, it's best practice to increment the ID by 1 for each successive insert. Follow this convention when fixing the bug.
I'm gonna try running it. Criteria failed unit, constraint failed user ID. Okay, so user ID. Do the first one. That's this one. Values 1. Well, that was the only problem was, so you had these two accounts that were entered in, but these values of the ID right here are primary, so you can't primary constraint. So run the code notice that this bug, there's violation of a primary key constraint on the ID column, fix the data. Okay, so because primary key works as unique, where it can only be one constraint, can be explicitly specified on a column to ensure uniqueness, rejecting any inserts where you attempt to create a duplicate ID. Okay, so it just couldn't be the same one. But there's also, what is it? Uniqueness does the same thing. So even the username has to be different. Usernames, 1, 2, 3 down. So 1, 2, what? No, that's the age. Oh, this is a username right there. So even the username has to be different than this one. So if the username was the same, I'm assuming, okay, let's remember, this says Jerry Smith. But if I put this here and run it, then you have an error because the usernames can't be the same either. Unique constraint failed username. I changed it back. Oh wait. Oh, I did it in the wrong spot. Oops. Hold on. Ah, see, I got it. Yep, because that works the same way. The primary key works in the same way that the uniqueness does. But the primary key is supposed to work where it selects that column row. This is a trip. Oh man, I gotta go to the bathroom now. This is terrible. Well. Oh crap. What'd I do? Well, the coffee's getting to me. This is starting to get interesting. This is definitely slower than the Python stuff. Ugh. Okay. See. Foreign keys.
Foreign keys. Foreign keys are what make relational databases relational. Foreign keys define the relationships between tables. Simply put, a foreign key is a field in one table that references another table's primary key. Creating a foreign key in SQLite. Creating a foreign key in SQLite happens at table creation. After we define the table fields and constraints, we add a named constraint, where we define the foreign key column and its references. Here's an example. In this example, an employee has a department ID. The department ID must be the same as the ID field of a record from the department's table.
Wait, so foreign keys can be is a field in one table that references another table's primary key. Creating a foreign key in SQLite happens at table creation after we define the table fields and constraints. We add a name constraint where we define the foreign key column and its reference. Okay. Primary key, ID integer, primary key, create table departments, department name, text not null. Okay. Create table employees, ID integer, primary key, constraint, FK department, foreign key, department ID, references, departments.
FK departments is the specified name of the constraint. Constraint FK departments.
Okay, in this example, an employee has a department ID. Okay, employee has ID, department ID. Okay, must be the same as the ID field from my record of departments table. Wait, whoa. So the employee can have the department ID foreign key, and it's referencing departments, this table's ID here. FK departments is the specified name of the constraint. So this is just the name of the constraint, I guess, in case you have to refer back to it and change it. Okay.
Create a constraint called FK departments. Foreign key department ID. Make this constraint a foreign key.
Okay, so you create a constraint, you have to name it, and then the foreign key, make this constraint a foreign key assigned to department ID field. Department ID goes right here, and it references the foreign field of ID that does not exist in this table back to the table of departments here. Okay.
Assigned to the department ID field. References departments. Link the foreign field ID from the departments table. Assignment. Our users table stores the country our users are from in a country code field. We need some additional data about countries, like their name, but we don't want to bloat our users table with all that country data. The locations team at CashPal has created a countries table, and we can link a user to their country by setting a foreign key in the users table. Creating a foreign key without the constraint keyword means the name of the constraint is auto-assigned. Take a look at the code. There's an issue with the insert statements again. Fix up the data so no foreign key constraints are violated. You'll need to reference the setup in the up.sql tab in the code editor.
Okay, foreign key constraint field. Okay. Okay, so insert into user ID, name, country code, values is 1, Jerry US, and then we have 2 Emmett. ID. insert into countries code. India. Foreign key country code. References countries code. Not no. So it already has the value insert into countries code names. Okay, so it already has the India and the United States of America NIN. That's it. I mean, it's because he had the wrong inserts. It wasn't supposed to be IND, just IN for India. Foreign keys, the country code. Country code here. That's India. Nope. Dang, that was it. Oh my god, that was super easy. I'm surprised it didn't have me create a foreign key though. Like honestly, like it just had me adjust it, but like into countries because yes, India. Well, that's fine, but like I thought it was gonna have me do this part, create a foreign key, country code, references countries code, and then create table countries code. Oh, this whole table. Yeah, I'll see. Create table users. Oh, so there's two separate tables. Country code US. Wait, I can't see the other table? There's supposed to be two tables. Oh. I was able to correct it. No big deal.
Schema. We've used the word schema a few times now. Let's talk about what that word means. A database's schema describes how data is organized within it. Data types, table names, field names, constraints, and the relationships between all of those entities are part of a database's schema. There is no perfect way to architect a database schema. When designing a database schema, there typically isn't a correct solution. We do our best to choose a sane set of tables, fields, constraints, etc. that will accomplish our project's goals. Like many things in programming, different schema designs come with different trade-offs. How do we decide on a sane schema architecture? Let's use CachePal as an example. One very important decision that needs to be made is to decide which table will store a user's balance. As you can imagine, ensuring our data is accurate when dealing with money is super important. We want to be able to keep track of a user's current balance, see the historical balance at any point in the past, see a log of which transactions change the balance over time. There are many ways to approach this problem. For our first attempt, let's try the simplest schema that fulfills our project's needs. Assignment. The architecture team at CachePal has decided on a single transactions table. The transactions table stores individual transactions, and we can keep track of the current balance on each transaction record. If we want the current balance, we can just look at the most recent transaction. Create the transactions table with the following fields and constraints. ID, integer, primary key. Sender ID.
I still don't understand. Okay. We've used the word schema. A database schema describes how data is organized within it. Data types, tables. Okay, so schema is just the way that they have it set up in that specific database that they're using. Okay, whatever. There's no perfect way to architect a database schema, so they're all going to have their own schemas, I guess. Choose a sane set of tables. How do we decide on a sane schema architects? We want to be able to, so okay, so it's the way we lay out the table. So what's important is keep track of the user's account balance, memo amount, balance. Okay. Create table. Integer primary key. Sender. I really gotta get in the habit of putting these goddamn commas. Okay, sender ID. Recipient. Integer. Oops, two O's. Oh. Memo. Text. Amount is an integer. No. Oh, God dang, these commas I keep forgetting. Okay, so I mean, that was simple enough. I've been doing that. But basically what they're saying is a schema is the way that this is laid out. Okay.
Relational databases. We have been using the term relational quite a bit. It's time we actually go over what that means. A relational database is a type of database that stores data so that it can be easily related to other data. For example, a user can have many tweets. There's a relationship between a user and their tweet. In a relational database, data is typically represented in tables. Each table has columns, or fields, that hold attributes related to the record. Each row or entry in the table is called a record. Typically, each record has a unique ID called the primary key. Example relational database. Here is an example of a small relational database. This database has 3 tables: students, courses, and student courses. The student courses table manages the relationship between the students and the courses tables. Example 1, Sam. Sam has an ID of 1. We can find Sam's courses by looking in the student courses for the records that match his student ID. Example 2, ASP.NET MVC. ASP.NET MVC has an ID of 2. We can find all the students enrolled in the ASP.NET MVC course by checking the student courses table.
Okay. How many courses is Sam enrolled in? Sam 1. I mean, I'm only seeing one course. No. Hmm. Oh. Oh, there's one. Oh, there's 1, 2, 3. 3. Oopsie doopsies. Okay, how many students are in aspect? I mean, this is 2, 1, 1. Okay.
Relational versus non-relational databases. The big difference between relational and non-relational databases is that non-relational databases nest their data. Instead of keeping records on separate tables, they store records within other records. To oversimplify it, you can think of non-relational databases as giant JSON blobs. If a user can have multiple courses, you might just add all the courses to the user record. This often results in duplicate data within the database. That's obviously less than ideal, but it does have some benefits that we'll talk about later in the course. Relational database, non-relational database.
Non-relational duplicates data while relational doesn't. So you can think of non-relational databases. Oh, I see. Because they're having to duplicate it right here. Because it can't relate it back, so instead it duplicates it like this. Non-relational databases connect similar entities by using nested data. Yeah. Cool. Oh, I can't. I reached the end of the free part. Dang. Oh, that was all the SQL. Let's see. Dang, I made it that far in Python. I feel like I barely even did anything. Oh, here's deep learning. Well, that didn't feel like that much to learn. I don't even feel like I can. I don't know. Let me see. There's like free coding courses or something. I mean, this is like, I don't know, $36 a month. And like, I feel like I'm fine learning the stuff I'm learning, but like, if I already learned what, like a third of this, then what the heck else is this gonna teach me? I just gotta go through all of it. Functional programming, AI. Build an AI agent in Python. I'm a shoot. Let's build an AI agent. I'm supposed to be studying, but I mean, I did finish that one. I mean, at least the free part of it. I could probably play a game real quick or something, but I'm also... Today's lesson done. Okay, now I see both the ones. Yeah, because even this one, I was digging this Python stuff. This was cool. I wanted to keep doing this. I don't know. I'm probably gonna mess with that more later on. The SQL stuff's really simple. Like, I don't know. Let me take a leak real quick. Let's see. Alright, we can play like a few matches, but I'm not gonna be able to play too much. I do gotta get the kids from school soon and stuff. But screw it, we can play a few matches. I'm probably gonna look deeper into this Python stuff because this is really interesting. I like this coding stuff. And I could do this on the side, but I'm also like, I really like being able to do this in this program. But I don't know. This is quite indecisive situations for this to continue going. Let me see. In this one. think this is what I was messing with earlier. Isn't that this? This was going really slow when I was looking at it. It was like... Yeah, this was like really like... They weren't even getting into the topic yet. This was taking forever.
I don't know what I did with my slippers. Oh, they're in here. You still streaming?
Yeah.
How are you doing on your lessons?
Well, I finished the SQL, the free part of it. But, yeah.
Okay.
I don't know.
You gonna take a break? I'm making lunch. Heating up some chicken Alfredo with some garlic breadcrumbs and some cheddar cheese. I think cheddar cheese would be good.
Yeah. Yeah, I was checking out this thing that you were talking about because other people have talked about it too. And the only thing about it is like, so the other website's getting straight into the coding, and this is just like asking a lot of questions and like not getting into the coding, and it's just like videos about the courses and stuff. And I don't know if it ever actually gets to the...
Take the intro, see where it goes. It's just the intro.
I spent like 2 hours yesterday going through intros.
My intro to real estate was like freaking forever. It felt like the whole intro course took me... It's supposed to be a 30-hour course. Took me like 4 days. Yeah. And it was just the intro. It wasn't even anything that I used on the test.
I was like, are we ever going to get to actually using anything? I was like... Oh.
Damn, 3 hours actually. Hey. Hi, Black Cat. Damn, babe. I don't know.
Yeah. I don't know. That's the only reason I like that other website, but I know this one, a lot of people talk about this one. But this one's like free. You just don't get
You can pay for the courses if you want, but
I just don't know if it ever gets to the freaking course.
It's gonna be the same thing. You'll pay for it, and you're gonna end up still having to do the intro and being like, it's on a time crunch. You got to do it on its hours when the tutor and everything's there. So, Danica's on the phone. Say hi.
Hi.
She's replanting her plants. I'm replanting my plants. I did the dishes. I did the wash, load of laundry, and I'm baking food.
You put on a load of laundry?
Mm-hmm.
Did you put any clothes up?
Motherfucker, didn't I just say I did dishes? I put on laundry. I'm making food, and you were like, but did you put up clothes?
Well, I'm just asking because that's the one thing. Like, you'll wash clothes.
What have you done today? I just got my coursework back.
Studying SQL.
Yeah, it's not enough, huh?
It's not enough.
See the lady in the relationship? Look at her. Isn't she gorgeous? Mwah. Bye, my sweet wife. I love everything that you've done for me, and thank you for making me lunch. Oh, I know. You're welcome, babe. You're welcome.
Hey. Hey. I don't know. This is the one I was looking at the other day. She was wanting me to look at this one, and I don't know if this thing, like, it's just not getting into anything. It's taking forever, and like, you listen to this guy talk, and he just like...
Okay. We want to start thinking about how do we get a computer to do things for us. So we can start by saying, well, what do we want a computer to do? We want it to compute something. Sounds like a deep philosophical question.
I mean, he's talking. It's okay to talk. But I would just want to get to the stuff. You know what I mean? He's kind of just like talking about it. None of this information is necessary. Like, it's fine. It's cool. But like, he's not teaching anything at the moment. He's kind of just like reviewing. I don't It's not that you will have to answer all the questions for you. Okay. What is this? It's graded. Okay. What is the difference between an algorithm and a program? An algorithm is a conceptual idea. A program is a concrete instantiation of an algorithm. I don't even know how to say that. An algorithm is limited to mathematical operation. A program can specify all kinds of operations. That sounds on point. The heck is this? I don't know. Makes slow programs run fast. An algorithm deals with computer hardware. A program deals with computer software. Okay, I think it's this one. True or false? A computational mode of thinking means that everything can be viewed as a math problem involving numbers and formulas. True or false? Computer science is the study of how to build efficient machines that run programs. I guess the two things every computer can do are perform calculations and remember the results. Ugh, I got a lot wrong. Algorithm is conceptual idea. Program is a concrete. Okay, let's try that and then that. Yep, that was it. Okay. Exercise 2. Oh my god, how many are there? True or false? Declarative knowledge refers to statements of facts. I believe so. Imperative knowledge refers to how-to methods. I don't think so. A recipe for deducting the square root involves guessing a starting value for y without another recipe to be told how to pick up the starting number. The computer cannot generate one on its own. I don't remember him saying anything about a imperative method. This dude's. I just want to get to the coding stuff.
We've described a recipe. We said it's a sequence of mechanical steps. It's going to capture the sequence of things I want to do in order to compute something. But now I want to get it inside the computer. I don't want to just give it to my friend and have him do all the work for me. So the next question is, how do I capture a recipe inside a mechanical process? Go back to my square root example. I'd like to get a machine that's going to compute square roots for me. Historically, there were two choices here. The first one was to use what was called a fixed program computer. And this would be a computer designed specifically to calculate a particular computation. You've actually seen them. Actually, you may be too young to have seen them, but people my age have seen them. Handheld calculators were a fixed program computer. They did addition, subtraction, multiplication, a simple set of arithmetic operations. That's all they could do. If you wanted it to search the web, good luck. Wasn't going to happen. Very famous historical example was Alan Turing's bomb. This was a machine designed during World War II to break German codes for the Enigma machine. And it was designed...
Thought you wanted something. No.
Specifically for that process. It was also built out of devices you don't see anymore, like vacuum tubes and relays.
Hey, what'd you say you were making?
I'm using the leftover chicken Alfredo and baking it with some broken up garlic bread and cheddar cheese or mixed cheese on top.
Oh, you already started?
Yes.
Oh, okay.
I just need to use the leftovers and the baby's hungry and
Yeah.
it's almost 2 o'clock.
I don't know when that deli bread goes bad. But I don't want it to go bad, because those look good.
Okay, well, you can make you a sandwich then.
No,
I'm not making you a sandwich.
I'll save it.
I'm changing now, so I don't have to change later.
No. Clothes.
Mm-hmm. For my rendezvous.
A lot
What?
of tongue rolls.
Huh?
A lot of tongue rolls.
No, Hispanic. We roll our R's.
Oh yeah. You gonna start speaking Spanish now or what?
You like it when I roll my R's. I'll see you complaining. I need a bra. This sports bra is killing me.
No. Well.
It's too tight.
And you can imagine the challenge of building such a machine, but it was designed to be a fixed program computer. That'd be boring if that's all we could do. I don't want to have to carry around a computer for square root and a computer for cube root and a computer for quadratic root. You get the idea. The alternative is what's called a stored program computer, and that's what you're used to seeing. Difference with the stored program computer is that you can load into it that description, that sequence of instructions, that recipe. And then inside that computer, there's going to be a set of parts that are going to do those instructions when I ask them to. And in particular, there's going to be a special program inside the computer, typically called an interpreter, which when you start it up is going to walk through each of those sequence of instructions in turn, doing the computation I want. And the advantage of a stored program computer is I can load in a different program and have it do the same thing. In essence, that stored program computer is emulating or imitating a fixed program computer for each program that I load in. It gives me an infinite range of things that I'm going to be able to do. So what I want to now think about is how do I take a description of a process in those mechanical steps and write it in such a way that I can load it into the computer and the computer can do the work for me. Before I do that, I need to think about what's inside the machine. So we're going to take just a second to open up the hood and look inside a typical computer. Basic machine architecture of a computer has some simple pieces. It's obviously got some memory, places in which I'm going to store things. Now up here in this memory it could be data, but it also could be a sequence of instructions that are my program, that mechanical set of steps. I haven't said exactly what they look like, but you got a sense of them from what I did in that square root example. I'm also going to have a way to load things into the machine and print things out of the machine, input and output. We'll come back to those later on. Inside the heart of the machine, there are two elements. The first is often called an ALU, an arithmetic logic unit. And what this unit does is it takes information from memory, reads it in, often two pieces of information if I'm going to do an operation that takes two inputs. It's going to do a primitive operation, could be addition, could be subtraction, could be testing to see if something is true or false, and then typically it's going to store stuff back up into memory. To make that happen, we need one more piece, and that's the control unit. And that's going to keep track of what specific operation I want to do in that ALU at each point in time. And inside the control unit, there's an important thing called a program counter. So very simply, when I load a program into the machine, in a second we'll get into how to do that, but I load a program into the machine. It's a sequence of instructions up here, and the program counter points to the location of the first instruction. And when I ask the machine to execute, that program counter reads that first instruction. It's going to cause an operation to take place, and it's then going to add one to the program counter, which is going to take it to the next instruction in the sequence, just as we saw in the square root example. That's going to do another operation, typically doing some arithmetic operation, moving things back into memory, and it's going to increase the program counter. Eventually, we're going to get to a test, and that test is going to say whether something is true or false. And based on that, we're going to change the program counter to go back up, for example, to the beginning of the code. But that's in essence what happens inside a modern machine. Control unit tells me where I am in a sequence of instructions I've read into the machine, that stored program. That causes a simple loop inside the machine of operations. When I get to a test, it's going to potentially change the program counter. And when I get to something that says stop, it will, and it'll print something out on the machine. That's the heart of a machine. It's all there is inside a computer. All right, there's a lot of stuff inside there, but that's basically what the machine's going to do. And our goal is now to figure out how do we write that sequence of instructions so that the computer can do the things I want it to. To summarize, a stored program computer then is going to be that sequence of instructions. It's going to be built out of simple arithmetic and logic instructions. It's going to be built out of simple tests, and it's going to allow us to move data around. And associated with that is going to be this special program called the interpreter that's going to execute each of those sequences of instructions in order, changing things with the flow of control when a test says, I want to go somewhere else. And then finally, when I'm done, print out the answer. That sounds great. So what are the basic primitives? Most machines will come, as I said, with simple arithmetic and logic operations. But in fact, you can go even simpler than that. And if you go back to that gentleman I mentioned earlier, Alan Turing, one of the greatest computer scientists in the history of the world, Turing showed that you can compute anything with just 6 primitives. In fact, there's something called a Turing machine, an example of which is shown in that little image on the slide. A Turing machine is an infinite tape with a set of squares on it. In that, each square there's a symbol, could just be a 0 or a 1. And what Turing showed is if you have 6 operations, and those are move left, move right, scan, read, write, do nothing. With just those 6 primitives, you can compute anything that's computable. You're now panicking and looking to find a different class. Because if what you had to do was program a computer by saying move left, move right, read, write, scan, stop, you don't want to program. Fortunately, modern programming languages come with a more convenient set of primitives. But the fundamental idea is that with a simple set of primitives, you should be able to compute anything. Equally importantly, you don't want to just write everything in terms of addition, subtraction, logical tests. What you want to do is write descriptions, like that square root program that we talked about earlier, and then abstract them. And I'm going to highlight that word because abstract is going to be really important. You want to treat that
That's
square
what I'm
root
talking about.
as
This
if
is why I was
the
struggling with
manufacturer
this
had
thing.
built a
He's
little
just,
primitive and installed it in your
it
machine.
ain't getting to the
Want to be
root
able
of
to
it
use
at
it as if it
all.
was something
He's going
you
so slow about it,
And that's
giving
what
the
the power of
history
computational
lesson. I'm
thinking is
just
gonna
like,
give
I
us.
don't care about the history lesson.
One last thing about computation. Let's go back to that Turing machine idea. I said you could compute anything if you just had those 6 moves. There's some nuances to this. A more sophisticated computer scientist could debate some of those details. But there's a fundamental property which says anything that's computable in one programming language is in fact computable in any other programming language. Wow. That's amazing. It says, while you may get heated debates between people about whether Python or C or Fortran or Lisp is the best computer programming language, they're all the same. Okay, slight misstatement. Some are going to be easier. Let me rephrase that. In some languages, it's going to be easier to do some kinds of things than others. In MATLAB, it's easier to manipulate matrices. In C, it's easier to deal with web programming. But nonetheless, anything you can compute in one language, you can compute in any other language. And this is a property called Turing complete. It's one of the fundamentals of computer science.
This is not as entertaining as the other one. That's the amount of time to live. Nothing. True or false? A stored program computer is designed to compute process. One computation, such as a square root or trajectory of a missile. Yep. A fixed program. Wait, a stored. Oh, wait, no, I think I got it wrong. I think the fixed computer was the one. Okay, fixed computer is designed to run any computation by interpreting a sequence of program instructions that are read into it. I mean, it can do anything, but it can only do one thing. That's actually in it. Designed to run any computation by interpreting a sequence. Okay. I don't know. A program counter. What does it mean when we say that the computer walks through the sequence executing some computation? The computer says it just...
Do you want to have lunch at your desk, or you want to take a break?
I guess I could take a break. I don't know. This dude just talks around like I'm just like, man, I don't know if he's ever gonna get to the actual stuff. Oh, it's computer everything. It's computer. Man, I got so many wrong. God dang it. Oh my god. The dude's boring the crap out of me.
Yeah.
Holy crap. This is terrible. The other one's just like doing coding. This isn't even doing coding. He's just talking about the functions of a computer.
How are you getting it wrong? You play with computers all the time.
Oh, read it.
I don't understand the functions of a computer. I ask you to fix my stuff all the time, and you update it, and I'm good.
Yeah, I can fix your computer. I don't know what the fuck this dude's talking about.
Well, you need to know the functions of a computer to do coding for a computer.
I guess. I mean, it's like, it reminds me of the oil field whenever all the safety guys would come out. And they'd be like, yeah, you need to know these acronyms because these acronyms are important for our policies. And you need to know our policies because they're important. And I'm just like, you've never thrown a pair of slips in your life, have you there, buddy?
Love you.
That's just boring, dude.
Yeah. I mean, if you're bored, how do you think your viewers feel?
I mean, I got that dude. He's just...
Oh, he's chilling? He's still there?
He just wants to play Rocket League.
Oh, he's waiting. He's like, come on, go on a break, dog.
Right? He's like, play some Rocket League. The other one's awesome because it goes straight into actual coding. This one's just like... I mean, I could try to rough through it, but this is boring as heck.
Yep, I'm waiting. Dead ass for real, though.
I'm just watching this dude talk about, like, very minor stuff that I'm never, ever going to use in the real world of, like, coding.
Maybe.
He's telling me about the primitive
Hey,
way that
I'm not
a
arguing
computer
with you
works.
because my real estate class is just like that. Literally, Brittany says everything I'm learning. She's like, you're not going to use that. She's like, at most, you might use some of the contract information, but...
Yeah, that's why I'm wondering if I should just focus on the other one, because if I'm not... Because this ain't giving me nothing that's going to help me to get a job. Unless I pay for it, then it'll give me a certificate, but everybody's saying the certificates don't matter. What they care about is your
work,
you have to
knowledge.
use it, create stuff with it, and then show them what you've created. That's
Pretty
what
much.
they care about. Unless you have a bachelor's degree or a master's degree, but even then, with a bachelor's degree or a master's degree, they still want to see the work, see what you can create.
What's, are you doing which one are you doing?
I was
Just
doing
the coding,
the
or?
boot.dev. Well, yeah,
Oh.
because they have SQL and they have Python. They have a bunch of stuff on there. But I just did the Python, some of the Python, and then I did some of the SQL.
Okay.
But they actually go into the coding. I don't know if this ever gets into the coding. They had me download, because I usually use Visual Studio to mess with Python, but they had me download a different one to use Python with, which it does these basically the same thing as Visual Studio. It just makes Python easier to read and it debugs it.
So, I mean, it's beneficial. You said it makes it easier to read and it debugs it, so...
No, I'm saying the program that I already had, that's what it does. But they had me download a different one
that
they
make
wanted
it
me
easier.
to... No, it just does the exact same thing. It's just a different program that they want to use. Because they don't use Visual Studio.
You keep your mouth open long enough, I'm gonna put my finger in it.
What?
Because you were staring at me like, I repeated what you said.
No, it's been totally useless this whole time.
Okay.
That's what I'm saying.
Well,
I'll keep
everyone
doing
says use it.
it. Yeah.
So it's not just me.
Everyone does.
There's gotta be something to it.
Eventually it'll teach
Food's ready
me.
if you're hungry, I can bring it to you.
Okay.
Or you can make your sandwich.
Oh my god. This class right here feels completely useless. I don't know if they're ever this. Well, maybe this is the problem. It's Introduction to Computer Science and Programming using Python. It had me download something to use Python. It's not having me use Python, and then it's telling me dumb questions that have nothing to do with the real world crap. Oh my god, I'm sorry. I don't mean to complain, but this is driving me crazy. This dude right here, like, he seems like a cool cat. He seems really chill. Like, I'm sure he's a great guy, but I feel like what he's talking about is, like, information I don't really need.
So now we've got the idea
I don't want
of creating a recipe
freaking
as a generic
bang my
idea.
head.
We know a little bit about what's inside the machine. What we need to do is put those two things together.
I
We want to
hate
now
this
go from a
website.
description of a process to a specific set of statements that we can store in the
Creating
machine.
recipes. I already
so that
know
that
about
interpreter,
this.
That
Oh my
evaluator
god.
can then run those operations to use the primitives inside the machine to do the work for us. As we said, programming language is going to provide us with a set of primitive operations. And the next step is to start talking about how do we put them
This is
together.
so basic.
To do that, we use something that we call an expression. And the expressions in a language are simply more complex but legal combinations of primitives that the programming language will recognize. And we're going to start building those up. So you're finally getting to the stage, after all of this high-level discussion, of getting to the place where we're going to begin to get the computer to do something. One of the things we're going to talk about, though, is that any legal expression in a programming language, any computation, has associated with it a value. That value is the meaning of the expression, and that's going to be important. In part because if
This
we know we
dude's
want to
like
get to a
saying the most
particular
basic
computation,
stuff I've
we
ever
want to
heard in my
understand
life.
how do we
about,
get to that
like,
value and how do we
God, I don't know if I can skip past this stuff.
Your ADD.
I really
fucking you
hope
up,
I
huh?
can skip past this. Well, dude, he's saying like the most basic crap about, like, he's not getting, like, it's just like, good God, this is so slow. This is terrible. It's killing me. He's talking about recipes. Like, I already know what he's talking about. I don't know. Maybe in like 10 years he'll start talking about actually coding.
back out of that
Yay.
the sequence of steps, the expressions that are going to compute it.
He
for
said
us.
this is what everybody says to use, right?
So let's look at how we put this together. Every programming language can be thought of as consisting of a set of primitives, a means of combination, a way of putting those primitives together to create new expressions, and a means of abstraction, a way of taking some complex expression and treating it as it's a primitive. To talk about this in a programming language, I'm going to give you an analogy to a natural language like English. In English, what are the primitive constructs? They're words, lots of them, some of them more common than others. In a programming language, we also have primitive constructs. These are the atoms on which we're going to build things. And in a programming language, those are typically numbers, strings, or just sequences of characters, and simple operations, the things that were provided to us by the manufacturer. Addition, subtraction, comparison. Given those primitives, we want to put them together. When we put them together, we have to think about two different parts. This is taking you back to an English class, because we have both the syntax and the semantics. The syntax is that parsing of a sentence to know, is this a legal sentence or not? And some combinations of expressions are legal, some are not. For example, in English, cat, dog, boy is not syntactically valid. It does not make sense. There's no verb in there. On the other hand, cat hugs boy is syntactically valid. It is a noun, a verb, a noun. That's something that makes sense. The same thing's going to happen in programming languages. Some combinations of primitives are not legal. They're not syntactically valid. For example, this expression right here, The first part, we're going to come to this in a second, is a string. It's a sequence of characters enclosed in double quotes, followed by a number. It's not a legal expression. On the other hand, as we'll see in a second, this is a syntactically valid expression. It consists of a number, an operator, and a number. So we're going to talk about how do we put together legal expressions. What is the syntax of those, both in terms of simple combinations like this and how we do it when we get to more complex aspects of the language. Associated with every expression that is syntactically valid is potentially a meaning, the semantics. What does this expression evaluate to? And here we're going to separate out both static semantics and full semantics. Static semantics tells us which syntactically valid strings actually have a meaning. In English, in bad English, the sentence, "I are hungry," is not actually meaningful. It's syntactically valid, meaning it's put together properly. It's, in this case, a pronoun, a verb, and then an adjective. Perfectly legal combination, but semantically it doesn't make sense. Same thing happens in a programming language. The first expression, 3.2 times 5, is syntactically valid. The second one, 3 plus the string high, is syntactically valid. It is a primitive, an operator, and a primitive. But semantically, it doesn't make sense. I can't add a number and a string together. So we have to distinguish things that are not semantically, are statically semantically valid, because they're not going to be expressions we want to try and assign a meaning to. Once we have both syntactically correct and static semantically correct expressions, we want to then know what's the meaning associated with them. And we're going to start building this up. Semantics then is the meaning associated with that syntactically correct string of symbols with no semantic errors. Even here there can be some wonderful nuances. In English, we can have a sentence that's both statically semantically correct and syntactically correct, but can have multiple meanings. Flying planes can be dangerous.
I'm struggling.
Does that mean if I'm flying it, it's dangerous? Does it mean if they come out of the air and crash on you, they're dangerous? There are multiple interpretations to it. Or from an old joke, this reading lamp hasn't uttered a word since I bought it.
This
Obviously
reminds me of
playing
my
on the word
grandpa,
reading lamp.
like
in a
whenever
different
you
way.
like, or
Different
whenever you
meanings associated.
have someone explain something
In
and
a
they
programming
explain it
language,
like 10
there's both
different
good
ways,
news and bad news.
and you got it
The
the
good
first
news
time.
is any syntactically correct and static semantically correct expression in a programming language will only have one meaning. But the challenge is it might not be the meaning you intended. And that's where bugs are going to show up. And we're going to come to that as we go through the term. But these pieces now are how we're going to talk about the language. What's the syntax of putting things together, and what's the semantics, the meanings associated with them. With those three things in mind, you can ask what could go wrong. And these are also things we're going to see in the course. First of all, I could have a syntactic error. I've not written down a legal expression. These are common and easily caught. And in fact, most good programming languages or the environments that interpret them will catch those directly. As you'll see as we go along, and I'm sure I'm going to make some mistakes as I do some work here, Python will catch those right away, so you won't try and do anything with them. Once you got something that's syntactically correct, what about static semantic errors? Things where things are in the right order, but they don't make sense. Some languages are very strict about catching these. They'll actually check before you ever run a sequence of operations to make sure there are no static semantic errors. Other languages, and Python is one of them, will do it on the fly. As you're going through a sequence of instructions, when it comes to one that is not statically semantically correct, it will stop. That's good news, but it can lead to some unpredictable behavior, and we're going to see that as we go along. The bigger problem is one where there are no semantic errors, but you get a different meaning than what you actually intended. These are the bugs that are challenging and are going to be difficult to find, but you need to find. And what are some of the consequences? The program could crash, simply stop running. Even worse, the program could run forever or until you get really tired and stop the machine because it's not coming back with an answer. And even worse yet, the program gives you an answer, but it's different than what you had expected, and you're going to use that to now do incorrect conclusions based on that error in computation. So what we're going to do now is start talking about Python, and our goal is to learn the syntax and the semantics of this particular programming language. and then to use that to learn how we can translate our recipes for solving a problem into a form that can go into the computer so it can run through that very mechanical sequence of steps to compute the things that we want to do. And finally, as we do all of this, we're going to start seeing patterns of computation. We're going to build up computational modes of thought, different styles of solving problems, because those styles are going to be common and can be easily reused when we see a new problem that fits into the same category.
Choose the term described by each of the following definitions. Determines whether a string is legal. Whether the string has meaning. Assign a meaning to a legal sentence. Holy god dang. Whether a string has meaning. Whether a string has legal sentence. The choice of words on this is driving me crazy. Has meaning versus legal sentence. I mean, this is... Static semantics means that it could mean something, but it doesn't fully make sense. Semantics is that it's just not in the correct order at all. So I would think that would mean that it doesn't have meaning, and this would mean that it's not a legal sentence. But whatever, I don't know. I guess that's how it works. I don't know.
Now that we have the idea that we want to put together expressions by putting together primitives in legal ways, we can take up that idea of how to use that to start capturing recipes, start capturing algorithms. So let's talk about a Python program. Python being the language we're going to use in this class to do programming. And a program, just as we saw with the recipe, is going to be a sequence of definitions and commands. Definitions, as we'll see a little bit later on, are ways of either assigning names to values or, more importantly, creating procedures that we're going to treat as if they're primitives. Those we refer to as being evaluated. Commands are simpler expressions that we can execute directly within Python. And we do that in something called a shell. And in a moment, I'm going to use a shell. A shell is simply a window into which I can type expressions. They get passed into the Python interpreter. It follows a set of instructions to figure out what's the semantics, what's the meaning associated with that expression, and then it prints out the result. Commands are statements that instruct the interpreter to do something. So the commands could be simply do this arithmetic operation, or commands could be apply a primitive that I created to do some work for us. The last piece, and we're going to see both of these as we go through the course, is that we can either type things directly into the shell. That's a window that the interpreter is listening to. That's something where we type something in and the machine does something with us. Or we can store it in a file that gets read into the shell when we're ready to use it, but otherwise can be saved away. To start with, we're just going to type directly into the shell, but we'll see examples of files in a little bit. Okay, we're almost ready to start programming. We know the pieces we need. Let's start with what are the fundamental primitives that represent data. Those we call objects. And programs manipulate data objects in order to get out parts of those objects or to do something with those objects. Every object has a type associated with it that tells us what kind of thing it is. And more importantly, that type is really important, that type tells programs whether they can act on it or not. If a program is expecting a number and I give it a string, it's not going to try and do something with it. So the type of the object is really valuable. Finally, objects come either as scalars, which says they can't be subdivided, or if they're scalars, obviously non-scalars, which are things that have internal structure into which we can pull out parts. Let's start with the simplest version of these. Scalar objects in Python. There are very few of them. We have ints. These are integers, standard numbers that you recognize. 5, 17,
somewhere
27,
with this.
-6. We have floats. These are real numbers, things with numbers after the decimal point, 3.27, 3.14159, my favorite. You have something called a bool, short for Boolean, and that represents true or false. Those are going to be important when we get to tests, because we want to know if a test is true, do something. If it's not, do something else. There's one weird one. It's called none type. It's a very special one. It has only one value, which is none. We're going to see why that's important later on, but just to be careful, none type is a scalar object. Those are 4 fundamental scalars. There are only a couple of more which we'll get to a little later on. Once I have knowledge of those different types, I can also find out the type of an object by using a built-in procedure called type. And I want to show you some examples. So I'm going to go over to my little machine over here, and I'm going to skip down. I'm now talking to a shell. And you'll notice it's got a little prompt that says in, saying what's the input you want to give. The fact it's got 30 on the machine is because I was doing some other work earlier. So this is going to be the 30th expression typed in. And I'm simply going to type in a number. And the output is the number itself. Well, duh, you say. But it's actually important.
Oh, I forgot. I downloaded a program for this. I don't even know where I put it at. Yeah, this thing. I need to make a shortcut. I thought I created a shortcut for this. I guess not. Oh, this is killing me. He's finally starting to talk something about it. But God. File location. Okay. Let's see. I should be able to put it right here. There. Alright, now I can get to that easier. Pull it up on my other screen. And then basically what he's using is this thing, but I have to use the spider one. It's the, so, I mean, it's not very different, but this is Spider, and it literally does the same thing that this other program I have does, Visual Studio right there. So I don't know why we're using this, but I guess that's just what he wants to use in the class. But, yeah. I'll put this over here for now.
Because what the machine did was it read in that sequence of characters,
3.5.
understood that it was a number, and the value associated with the number
If you
is
put
simply the number.
type,
And in fact, I can check it because guys can say, what's the type of 3.5? Notice the open and close parentheses around it,
floats.
and it says it's a float.
Easy.
And I can have
Come on now.
integers, and if
Come
I say,
on.
what's the type of that? It's going to give me back an int. Simple things. Okay.
Simple. So simple.
Again, just to recap, what this says is here's what I'm going to type in to this Python shell, and here's what shows up after I after I hit enter, as you just saw. And in and out are simply going to identify what I typed in and the output that you recovered. Sometimes I want to change types, especially with numbers. This is called casting, and I can cast types of different forms. And you can see the example. If I say I want to take an int, such as 5, and turn it into a float, I can ask it to do so by giving it the special command float, the thing contained within parentheses, and it converts it. The other direction also works. If I want to take a float, such as 3.9, and convert it into an int, here you say, boy, there might be some choices. Python simply gives the whole number part of it. It doesn't round it to the nearest integer, as you might expect. If you want to build your own programming language, knock yourself out, you could do that. But it simply will truncate it down to that int. So I can convert back and forth. Now, once I've got these things, I can start putting things together. And in particular, here's a legal expression, 3 plus 2. That has a value associated with it. In fact, that expression is to take the 3 and the 2 and apply the arithmetic operation of addition to them. And when I evaluate it, it simply returns out 5. Makes sense. Sometimes I might want to use something that's going to print, and I can type, for example, print, which controls output to the console by saying print 3 plus 2. Little bit of a difference. And in fact, there's no out here because no value is returned. Print returns that none type and doesn't print anything out. It just printed something. At this stage, you may be saying, well, why do this? Why the difference? What we're going to see is when we're in the middle of a computation and we want to print something out to the shell, we can use a print command to do that. If we just return the value, that goes back into the computation to be used for the next step. And so in the simple first case, the whole value of the computation was 3 plus 2 equals 5. It was printing out 5. In the second case, the side effect is to print something. The value returned is nothing. There is no value. We'll come back to that as we go along. I've already hinted at this, but now we can start putting things together. To combine objects and operators into expressions, we use a standard form. And the syntax is simply an object, an operator, and another object. Any expression like this that is syntactically valid has a value, which is itself a type. So we talk about the types of scalar objects. We talk about the types of more complicated expressions. What would those expressions look like? Well, here's the first set of them. There's a lot on this slide, but you're going to get used to them, and most of them make sense. If I want to add together either 2 ints or 2 floats, my expression is to have 2 numbers as I just did, 3 plus 2. The value associated with that is the combination of adding the 2 things together. I can subtract, I can multiply. And for these examples, if both I and j are ints, the result is an int. If either of them or both of them are floats, the result is a float. And let's look at an example. If I do 3 plus 2, I get 5. If I do 3.0 plus 2, I get the float 5. So Python is always using, if you like, the higher level representation when it does those kinds of operations. Division's a little trickier because I have both standard division, which will be a float, and I have integer division, which will be the quotient without the remainder. And let's look at 2 examples. If I do 5 divided by 2, I get 2.5. If I do 5 with 2 slashes divided by 2, I get the integer part, which is 2. The 0.5 is thrown away. And if I wanted to get the 0.5, I could do 5 remainder 2, which is the percent sign, and that gives me the piece left over when I divide those 2 pieces together. Finally, I can raise something to a power, and that is done right here with I 2 stars j. So 1 star is multiplication, 2 stars gives me power. Once I've got that, I'm ready to start putting together pieces. In particular, I've got different operations, so I have to think about how do I put together pieces in ways that control what I want it to do. And here we're going to use parentheses to tell Python in what order to do the operations. There's a precedence to those operations, and those are shown right down here, going in this order. Exponentiation, powers, are always done first. Then multiplications, then divisions, and then finally additions or subtractions. And overall, it's done in a left to right order as it appears inside the expression. And that means that as I change where the parentheses are, I'm changing the order in which I'm doing things. So to do an example, if I take 3 times 5 plus 1, that's going to give me 16. And that's because the multiplication is done first. 3 times 5 gives me 15. And then the addition is done to give me 16. On the other hand, if I say 3 times, and then in parentheses, 5 plus 1, the parentheses say reduce this expression first. Add 5 and 1. That gives me 6. And then do the multiplication, which gives me the 18. As a consequence, I can create very complicated expressions, and I will simply use parens, open and close, to define what operations to do first. Always simplifying inside out before then using the operator precedence order in order to decide what the expression actually means.
Oh crap, I didn't mean to push that button. Okay. 6 plus 12 take away 3. 15. 2 times 3.0. I feel like I could do this in my head, but I feel like I have to do it with the computer just in case. Okay, so the first one is 15, 6.0, 4, 3.3333. I mean, I'm pretty sure that's going to have the same results, but I guess I should go ahead and make sure.
I spazzed out for no reason.
Yep. And then 2 plus 3 times 4 equals 20. That should be the same answer. God dang. Better make sure. 2 plus 3 times 4. It's not. It does actually multiply before it adds. I'm surprised. Well, I learned something. Okay, 2 to the square root of 3 plus 1 equals 9. And then 2.1 to the square root of 2.0 equals 4.41. 2.2.
Apparently people are panic buying food.
Because the freeze.
Yeah. Some people got stuck. What is it, like a week of that crap, right?
Yeah, last time it happened, it was pretty bad. People go crazy, especially with toilet paper for some reason. I don't know if the toilet paper situation will happen again,
Do
but...
we have toilet paper? Well, we have a
Bidet.
bidet.
Bidet. Hey, I used a bidet earlier, and after I used toilet paper afterwards, just in case, and there's like nothing on the toilet paper. I was like, dang, but then sometimes I use it, and like, I guess my poops are pretty nasty or something, because sometimes I wipe it with toilet paper, and then I'm just like, oh, just in case a little bit still left.
Wow.
Yes.
I'm glad
Then
you
it
still
sprayed good enough, apparently.
bidet. You needed a jet blast like the first time it got me.
Look, I'm finally using Python. It took him long enough, but I'm doing the most basic stuff I've ever done in my life.
You understand the basics.
Hey,
You're
I
unstoppable.
already know how to do this stuff, but,
That's
you know,
okay,
maybe
yeah.
eventually.
By 5
This
days
is,
later.
God, this is so slow.
Hey, but you're doing it, you know. The
Mother
EDX It's
God.
you, free education, man. Sometimes you have to pay some way, and time is money. So you're paying with time. Yep.
This is so slow, dude.
Hey.
He barely just started barely touching anything.
He's dropping his paid for knowledge for free, though.
Yeah.
I'm gonna go get the kids here in like 20 minutes. And I'll come back.
No. I mean, shit is free on the other one. But in order to interact with it, I have to basically do the same thing I'm doing here. Or I have to pull up a separate program. Because they have it to where you can use the program in it like this. And all this is this. But instead, it's on the same website. And if you pay for it, then you can keep doing this. And it'll check your answers and tell you if you're right or wrong.
Well, Python will check your answers, right?
This, it'll tell you if the program is running or has an error.
Hi, cars.
Cars?
Yeah, you cars.
Dude, that's a lot more than just cars. It says UT Cars Shingha 4303.
That's awesome.
Hey, what's up? What's up? What's up? I'm sorry, I just saw your message. I am being forced to use this boring website instead of this very more interesting website because
he's not being forced. He's doing it.
Apparently, this is more better to more people. I have yet to discover why.
Because it's awesome.
It's the dude. He's barely talking about how you can do math. Like I already know. I'm like way ahead of this part. Like, oh my god.
Makes your hair soft too. I like it.
This is insane.
Well,
oh my god, is he doing more, man?
Dude, people are freaking out.
So simple.
Well, we have enough propane. We have tiny propane bottles for the cook stove. I think we're on the grid, so we'll be good. And we have plenty of firewood. So.
For the freeze?
Yes.
Okay.
I want to put some blankets outside on the pipes just because I don't want to risk it. I'll let you get back to it.
Okay, spend time to play 3 minutes. Below is a transcript of a session with the Python shell. For each expression being evaluated, blah, blah, blah. Assume that the expressions are evaluated in the order shown. That is, each problem part is evaluated directly after its previous problem part. So a equals 3, a plus 2 is going to be 3.0. That's going to be a float. If a equals a plus 1.0, what is a? Well, then a is this all the same? Is it the same function? Assume the persuasions are evaluated. I mean, look, if you do, okay, look. If I do a equals 3, right? A equals 3, right? And then I do a plus 2.0. That's going to give me 5.0, right? Okay, and then a equals a plus 1.0. What will that do? It does nothing, okay? And then what is a? 4.0. Huh? A equals a plus 1.0. So you subtracted 1.0 from it? God, so weird. I don't understand this. And because a equals a point, you can a, like it can a itself. This is wild. Okay. That's weird. A equals 3. And B, what is B? B is an error. It's nothing. What are you talking about? We never used B. B doesn't equal anything. Select option, none. is not defined. Okay, I'm right about the none type, but what does it want me to put here? B? No. 0? 0 would be something. None is none. Why is this wrong? Oh, I'm supposed to put error? Like, it doesn't just say error. Okay, for one, it says, look, here, I'll show you this. Look, here's proof. It doesn't just say error. It says name error. Name error. Right there. And then it's in 22, and there's no out because it's error. So yeah, no, it doesn't just say error. It says name error, and this is the one that they want me to use. So, swear, Jesus. All right.
So we've now seen the beginning of programming. Simple expressions, ways of putting them together into more complex things with means of combination, and the very first version of abstraction, giving name.
Are you guys in a hot area or a cold area? Because I mean, you're in Canada? Hold up. What? How cold is it in Canada? Dude, it's 62 right now, but it's about to get hotter. Or colder. Oh my god. What? Canada? What are the temperatures in Canada right now? 40 degrees right now. 40 to 30. Oh. That's pretty cold. Yeah, it's like way colder up there. That's crazy. No, it's like 62 degrees here. But it's going to drop down to like the 30s and 20s. That's why everybody's freaking out. Because we live in an area that is not prepared for cold. We are not used to getting cold weather. We're in North America, but we're on the south side of North America. As south as you can get before you start speaking Spanish.
To things. But so far, all we've been able to do with these pieces is just behave like we're a simple calculator. We can do arithmetic. Let's add one more piece in, which is the ability to make decisions based on tests. And for that, we have to compare things. We have to decide, am I close enough to square root that I'm done? Am I close enough to something else that I'm done? So we have to be able to compare things. And since so far we've just talked about numbers, what are the comparison operators for integers and for floats? They're the things that you might expect from arithmetic. If I and j are any names of variables, they have values as numbers, then we have ways of testing if something is greater than something else, if something is greater than or equal to something else, less than, or equal. So is 2 less than 3? And if I do a simple example over here, 2 less than 3 returns true. That's good. 2.0 greater than 3.0 returns false, also good. Is 2 less than or equal to 2 returns true. On the other hand, is 2 less than 2 returns false. Simple comparisons. I also want to be able to tell when something's equal. And you might think, oh, that's easy. Is 2 equal to 2?
Alright, love you.
Getting the kids.
We already used
Alright.
equal as an assignment statement. So that won't work. And as a consequence, equality is done with double equal. Is 2 equal to 2? So for example, 2 equal to, oops, try that again, returns true. And then finally, if we want to know is something not equal, we use the exclamation point followed by the equal sign, often referred to or pronounced as bang equal or not equal. That will return true if I is not equal to j. Simple comparisons. They're going to let us build the very first kinds of programs that are going to let us make decisions, because based on whether something is true or false, I'm going to be able to decide which operation I want to do next. You're going to get a chance to explore all of these, but these make sense because they're simple arithmetic things other than that double equal sign, which, as I said, is there because equal is already reserved. Once we have logical expressions, we also need to be able to combine them. I might want to say, is something less than this and greater than something else? And so if I have two expressions that are Booleans, I can also combine them using either and, which is true if both are true, or, which is true if either of them are true, and of course not, which will be the opposite. Not A is true if A is false if A is true. Once I've got those pieces, I can put together more complicated expressions to decide tests. How might we use these? Well, here's a simple little example. This is actually a map of MIT. MIT students are always looking for free food. So imagine there's some food stored away somewhere at MIT, and I want to give instructions to a student to find them. All right, this is a complicated map, but we could use a simpler version of it. I've got my student. He's over here with his backpack ready to find that free food, which is way over here, and I want to think about how would I instruct him to get there? What would the tests be that I might want to use? Well, I might say, if you can go to the right, keep going to the right. On the other hand, if you get to the right and it's blocked, change and go forward. Unless both the right and the front are blocked, in which case go to the left. Unless all of them are blocked, in which case backtrack. Won't be perfect, I could still get stuck, but this will work pretty well to get my way through a maze. What I've just described are 4 simple tests to let me think about how I would instruct somebody to solve a problem, in this case trying to find the free food. Oh yeah, I need one more thing, which is to test when I found the food to know when to stop. Simple tests. With those ideas, I can put together the first kind of actually more reasonable or interesting program called a branching.
Whoa. Oh, Celsius. I don't know what Celsius is. We use Fahrenheit. Oh, it's 1 for every 33.8 degrees. So, what is that? Negative 25 is, oh my god, that's negative 13 degrees. And then negative 50 is negative 58 degrees. Ugh. What is 62 here? 62 degrees is apparently 16 degrees. 16 degrees Celsius. How does Celsius work? Celsius is so weird. What the heck? I don't know how y'all go off of Celsius. This is a trip. Dang. Because it's just like, it subtracts a certain, I forgot what Celsius goes off of. So I know Celsius, because Fahrenheit goes off of 100 degrees is boiling temperature. And then Celsius goes off of something else. I think it was like 0 degrees is like freezing temperature, because freezing temperature in Fahrenheit is like 32 degrees. Hold on, let me put 0. What? I don't know what I did. Let me do that. Okay, 0 degrees. Yeah, that's what it was. So Celsius is 0 at freezing temperature, and Fahrenheit is 100 at boiling temperature. They're like opposites. I don't know. But, and then Kelvin is another one, and Kelvin is supposed to be the temperature of space at 0. It's like the absence of heat. Yeah, but is it weirder? I mean, it's only just like it's barely off. They both basically do the same thing, but they're just set at different points. So the values are the same, but all you have to do is add or subtract that 32 degrees. So that's what's a trip about it. But I will admit to you, you're not wrong. I feel like America purposely just uses different things, because a long time ago, it was like everybody uses the metric system. Like everybody else in the world uses, degrees Celsius and like millimeters and stuff. And we're over here like using feet, inches, miles instead of kilometers. We use Fahrenheit instead of Celsius. Like it's a trip. And so like, because we like, and I don't know if all cars are designed like that, where you can switch the kilometers and the miles, but all our cars have miles set. But now you can go in and you can, like, tell the computer to, like in our cars, you can tell it to change it to kilometers and it'll swap it over. But our older cars only show miles per hour. I don't know what they're like. I don't even know if Canada. I think Canada goes kilometers. I think literally America is the only one that uses miles. I don't think anybody else uses this stuff. And then we got like inches and feet that nobody else uses instead of meters. But it's not like we don't know about it. We use it, but we don't use it. And it's like whenever we get tools, we go off of tools like a 1/2 inch or 7/16 inch, or you know what I mean, like stuff like that. And then everybody else is just going off of millimeters for tools. It's a trip, dude. So there's so many different things. And we're like, America's just like, we refuse to use the same numbers that everybody else uses. But yeah, it's 62 degrees where we are, which actually it was like, 70 degrees the other day. So I guess 16 degrees Celsius. That's so weird. Because, I don't know, 60, like just that temperature I get pretty cold at. I'm used to like 80s. What is 80s? 80s is 26 degrees Celsius. So. Wait, you know what? That's not right. Because 80 take away 32 doesn't equal 26. Man, what? Uh, 80 take away 32 equals 48. So, does Celsius work differently? Oh man, this is really gonna mess with me. I thought it was just... What? Oh my god. Wait, so it isn't just subtracting. No, it really is. It's more than that. So, oh man, well, I don't know what 0 degrees Fahrenheit is. It must, okay, so 0 degrees Celsius is freezing temperature for water. This is so confusing. Yeah, it's totally different. Huh? What? What's wrong? You want to take your boot off? I'm gonna get another soda. Maybe some more water. But see, here's another thing. This is why I used to get so freaking bored in school, was because they used to drag stuff out like this. There was a lot of times where I was in school and I would be excited about certain things that we would learn or certain things that we would do, and the part that would kill my excitement and bore me to death, especially because I got ADD, so it's really hard for me to concentrate as it is, was they would like talk around the subject so much without actually getting to it, you know. And I'm just like, I'm one of those where like I don't want to walk and skip and, you know, hover around it. I just want to get to the root, the meat of it. I just, you know, it's like, God, Jesus, that's like the school stuff, dude. They like they walk around it for so long before finally getting to it, and you're like, just tell me, just get to it, just freaking, you know, like put the pen on the paper and do something. Like I can't just it's just. Anyways, he's finally moving into stuff, and he's explaining this stuff so slow. And I mean, I guess I get it, because you are talking to people that have like very different levels of knowledge and very different like speeds of picking it up. So I'm like, I mean, I guess I get it, but it's like driving me crazy.
Called a branching program. And it would say in that case of the maze, move forward unless a test is true. That test might be moving to the right is blocked. If it's not blocked to the right, I'm going to do one thing, keep moving forward. If it is blocked to the right, I'm going to move ahead. And a branching program then simply consists of a test, something that's going to return a Boolean true or false. If the test is true, it's going to have some code that tells me what to do in that case. On the other hand, if the test is false, it's going to have some code to tell me what to do in that case. And in either case, once I'm done with those pieces of code, I can pick up the rest of the computation. You can see why it's called a branching program. It takes one of two branches based on that test. In Python, we don't necessarily have to have the false block. We have to have the true block. If this is true, there should be something I would do. But if it's not always the case that I want to do something even when it's not true, I can skip that. With that in mind, I can start now building a little bit more interesting programs. And so here's a simple example. There's some pieces here we're going to come back to. Don't worry about them. Pieces like input, which is going to give me a way to read something in. But what I want you to see here are the tests. And the first case of a branching program is an if statement. That's a special symbol. It is treated differently, and when the Python evaluator sees this, it says, given that's an if, I'm going to evaluate this expression, which should return a Boolean. It says if the remainder of x divided by 2 is equal to 0. Notice the double equal sign there. If it's equal to 0, if that is true, then I want to execute this set of code. It's going to print out a blank line and then print out the word even. If it's not true, I need to tell it what to do, and I use the special symbol else for that. These are often called if-else expressions. If this is true, do this. Otherwise,
Yep.
Here, again, I've got a block of code. In this case, it's going to print out a block.
Yeah, I already see exactly what this is. All this is like, so you're creating X is a non-existent thing that you're using specifically for the code. You're telling it X is an integer, and you're putting input. Now, when he's got this in parentheses, enter an integer, what it's going to do is when he actually runs this code and you see the, you know, the actual thing running, you will see enter an integer, and then you'll have to put a number. And then depending on what number you put, if it's equal to 2%, which is going to keep it at an even number if it's equal to 2%. If x is 2%, wait. If x percent 2 is equal to 0, print even. No, but what it's supposed to do is tell you if the number you're printing is odd or even, and then it's gonna say done with conditional, and that's it. So that's what this coding is. I mean, that's what he's creating a code for. I could probably create something like that, honestly, like. Okay, so look, I could do this. I'll just copy what he's doing right here. Hold on. In fact, I'm gonna see. Can I make another one? New window. Oh, that's not what I meant. Let's see. New file. Okay. And so this is x equals integer and okay. Input. Okay. And then I'll put enter in here. I was gonna put this over here so we can all see it. Oh, I already put in. Input an integer. All right. And then I can also put if x is %2 equal 0, print I don't know why he's doing this one. I guess just to keep an additional space. Print even. And then else. Says there's something wrong here and I don't know what it is. Print. Even. Oh, odd. My bad. That's all it was. I just need to keep it spaced out correctly. Okay. Odd. And then also print on with conditional. Okay. Then we can run the program. Enter an integer. Let's say 3. Press enter. Okay. So what this ends up doing. Ooh. That makes it look so much better. I see why I did that now. Alright. Let's try running again. Okay. Enter an integer. Enter an integer. And then let's say I put 3. And then I press enter. It will pop up odd, done with conditional. And then if I put 2 out 2, oh, because I'm not running the program. And then I put 2 even, done with conditional. And it should work, yeah, with any number. Right, put some crazy number like that. It's an odd number. Put some crazy number like this. What if I do decimals? That should be an odd number. Oh, we got a cog in the system because it said x equals an integer, and if I put a decimal, that would mean it's a float. So what else I could put is to correct this, you could put if input equals float okay, so now we can run this, and so like, okay, so this will still run the program, so that's odd. 4 is even, but if I put 4.54, oh, it still shows error. Huh. Input. Let me see. What if I copy this, put it over here? Ugh.
Someone is at front door.
Okay, so I see there's an error. I didn't think that that was gonna... If input... No, wait. Oh, no. No, I don't think I have to do that. I think what I have to do is... if x equals float, then print why does it always do that?
Baby, don't worry, you know where you got me. Are you still doing this? Get it, babe.
Well, I'm trying to see if I can come up with something myself. I don't think that's gonna work like that either, though.
Was it the red pill or the blue pill?
What?
To enter the matrix, man.
Oh my god. Still showing error. Invalid syntax. Okay, well, I can do that. That's what I did earlier, but expected. Oh, for this part. I feel like that should work. I don't know why it's not.
The GT goes fast, you say. That's a fast GT.
What are you talking about? I swear to God, you're so weird. Why'd you say GT?
Hold on. That's gotta be Charlie's music.
Oh, it's a Ford GT. Oh, that's a newer one.
Oh, that's pretty, right?
Did they bring them back?
Bringing it back! Hold on. So you see what... Don't put it in front of your camera and block everybody. And then the new GT. Look at that. Ooh, it's so pretty. I don't know if you like cars, but... Oops, sorry. I'm slapping. the baby fan. Oh. Alright, I'll stop intervening in your thing. What up, baby? Of course he's talking to you. He's your brother. He's gonna talk to you.
That still doesn't work. Okay, so it works regularly, but dang. I don't know what I'm doing wrong. Right.
Sorry.
Else. Else do after the if expression. Unless it doesn't like exactly where it's at. Oh, find this other one. Float argument must be a string or a real number, not non-type.
Oh my god, that's amazing.
Huh. get this done the way I want it to. Okay, screw it. Let's just do this. Well, okay, screw it. We'll see what else it does.
Blank line, and then the word odd. In either case, when I'm done with all of that, I'm going to go down to the rest of the code, which is just going to print out a simple thing that says I'm done with this conditional. You could type this in and run it. I invite you to do that. But what I want you to see here is a couple of things. This if, else structure. And I said in a branch there should be three pieces, and you can see them. There's the test. There's the first block, that's the true block. And there's the false block. Now, how did I know, or rather, how did Python know those are the blocks? Because of this indentation right here. The fact that those lines of code are inset are important because it tells us that's an entire block of code. And when I get done here, I'm going to pick back up the rest of the else. And more importantly, when I get done there, it tells me where the rest of the code picks up. Simple example of a branching program. I've already said this, but I want to recap it. I've got a test. It evaluates to true, when in fact in this case x divided by 2 has a remainder of 0. As I've already said, notice the double equal sign rather than a single equal sign to do the comparison. As I've also said, the indentation is really important. It tells us what pieces are associated together. And notice how that indentation gives us a nice visual structure for seeing where the code is, to see the semantic structure of the code. What's the true block? What's the false block? Now, it turns out that you can have nested conditionals. Inside of a block, I could also have a conditional. And that's perfectly fine. It says if this is true, then I'm going to go in and look at this portion. And if this is also true, I'm going to do that. On the other hand, if this is true, but this is false, I'm going to jump down here and run that, please. Again, I invite you to type this in and try it, but it's going to do something that, based on what the value of x is, prints out whether it's divisible by 2 and 3, by 2 and not 3, or by 3 and not 2, as it runs through that sequence of branches appropriately. And finally, we can have compound Booleans. As I said, I have things that can be combined. This is a Boolean, that's a Boolean, and the combination with the and also gives me a Boolean. So in this case, if x and y, if x is less than y and x is also less than z, then the combination is true, and I'm going to print out a particular thing. Again, don't worry about what this actually does. What I want you to see is the structure, including one last piece, which is elif, also shorthand for else if. This says if this test is true, do that. But if this test is false, then see if this is true. If that's true, do that. But if it's false, then skip down. In this case, there's an else, and I'll always do this. I could have multiple elif statements. It's a way of giving me a sequence of tests in order. If this is true, do something. If it's false, but this is true, do something. If that's also false, but this is true, do something, and so on. This just then pulls them together. I've got a basic conditional. If this condition is true, do a sequence of expressions. I can also have an if and an else, or I can have an if, a sequence of else, and an else. And again, notice how the indentation tells us which things to do associated with which block of code. That indentation is how we are going to capture other pieces as well, and it doesn't have to just be conditionals. I could have something that has other statements inside of it, such as a print statement here. Again, don't worry what this code does. It's a simple piece of code to execute some simple comparisons on numbers. What I want you to see is how we walk through the branches. And with that, we now have the first kind of code. There's one set of blocks, inside of which I've got another set of blocks. And again, if this is true and that's true, I'll get to that point. But if this is true and this is false, so true here but false here, what happens? Oh, There is no code here, so nothing happens. It simply skips out to the end and jumps past. Again, I invite you to try this to see if it works the way I've described it. What I want you to see is the form of it. One other...
Might as well do my typing practice. X.
They're raving in the room.
Party hardy.
I'm hiding from them.
Need a little break from them.
Just a little bit. Playing them all little games.
Not a bad idea.
Your homie's still waiting for you to play a little Rocket League.
Oh yeah, no, I haven't played it yet. Well, he finally started doing stuff that's, you know what I mean?
Yeah.
Something. I'm like, God, dude, like, well, cause I've been like looking at, well, I was using that other program too, and it was like way faster on the pickup, and it's like a lot of stuff he was talking about, like I already understood it. Oh, if y is not equal to 0, print, what would I do? Yeah, if y is not equal to 0, print therefore x therefore x is greater than y. Oh, what's up? Hey, what's Camacho doing? I heard he left the oil field. I don't think he's gone. Don't think he ever went back. Hey, what's up? That's some Russian digits. Oh, man. Alright. Let's try this out. See if I can guess what this thing's gonna do. So X is a float, Y is a float. Float means it's a decimal number. I know I got some people saying how. Well, I know Alex. Me and him used to work way back in the oil field days. X is a float. If I run it, oh, it's giving me an error. Oh, right here. Indents does not match the outer indication level. What? Print. Did I do this one wrong? LF. That looks right. I was sitting out too far, that's all it was. Okay, enter a number for X, 2.5. Enter a number for Y, 3.5. Thanks. That ain't work. Oh. If Y is equal or less than 0. If
So close.
X is greater than Y. It should be printing that. Why is it not printing that? Let's try. Huh. Oh crap. God dang it. Man, what the f-
Your reaction, I'm sorry.
What?
I'm smirking at you. Just the what the like.
I don't know what the fuck is not. It's giving me errors.
You
Things
got this.
pissing me off.
You definitely got this, babe.
I gotta have everything in a certain spot. Okay, enter X. X is smaller. There it goes. Okay. Oh, Jesus. If X is equal to Y, print X and Y are equal. So, okay, so if I run it again, that should work too. Let's do 2, 2. Therefore, okay. Therefore, X or what? X and Y are equal. So that's therefore X. Therefore, X is greater than Y. What? That's not. I should have did this one. Because I put the same numbers. That's not working correctly. Now they're equal. But they're 0. But then if I run it again and I put 2 and 2, then it puts that one. That doesn't make any sense.
Here, I'll be back.
If y is not equal to 0. You'll be back.
I know today's laundry day, but I don't want it to be.
Who said it was laundry day? You
I did, because we have clean clothes, we just gotta put them away. That's all shirts. I got all my pants. I just don't.
Washing was the easy part. Putting them away is
It's the hard part. It is, especially when our closet's not as big as I thought it was gonna be. Especially sharing. I love you.
Hey, you're the one that picked this house.
I love this house. Thank you for letting me pick this house.
You picked the closet, basically.
I'm okay with that. I'm not complaining. We just gotta work on my attic, and I'll just make my attic my closet temporarily.
What?
Get your feet off the bed with your shoes on.
My legs.
Come on. Then take off your shoes. That might be your style still. You nasty.
Sorry.
Love you. You want anything to drink?
No, it's fine, I guess. I don't know.
Pull down the music a little bit. Check on the littles. You know, they run house without us around.
They sound happy, so there's that.
Cora, turn down the volume. Oh, she ain't even doing her homework. Hold on.
Uh-oh. Better be doing that homework. Hello. Okay. Dude, this isn't working the way he says it's supposed to work. Because look, there's if y is not equal to 0, therefore x is greater than y. Therefore x over y is... Oh, but why would you put that? Oh, therefore x divided by y is 1. Well, that is true. If y is not 0. But I mean, you could have put that before. He's just showing you can put ifs on top of ifs, and then you can also put else ifs. Okay, so you put in. I see what he's saying. It doesn't matter what the process is. What he's doing is he's putting an if. Yes. I'm playing with the Python. I was doing SQL earlier, but now I'm messing with Python. I did like a little free trial with SQL, but I already finished it. So now I'm messing with Python. I was messing with Python yesterday, but I got to the end of the free trial kind of thing, and now I'm doing a different free class. So, but this one's not integrated into the website, so it's kind of like separate. So I have to run it. I mean, I run Python off of Spider. I was doing it on Visual Code before, or was it Visual Studio? But yeah. Yeah, this stuff's highly interesting for me. The way that they explain it in this website, though, good God, they are so slow. It is so boring.
Wine.
The last website I was using was way more entertaining, but I hear that this is what everybody's using these days.
Hey!
Is this
Am I the only one saying it, or other people?
EDX? Huh?
Am I the only one saying it, or other people saying it?
You're the only one that knows.
Ah!
I just don't know. No one else is saying anything. I don't know.
Okay.
No one's saying anything.
edx.org.
Yep.
Keep talking.
Because they got free classes, but you have to pay if you want a certificate. But the classes are free. So this one is more entertaining. And it's free to go through the classes, but you'll see you only get so much free, and then you get to guest mode. And when you enter guest mode, so you can see everything, but I can't like type anything in here anymore because it's no longer free. But what I can do is the exact same thing I'm doing with the other website, where like I can take all this, put it into here, and then test it myself instead of testing it off the website that they have. So there is a way to do it on here for free, and you can go and look at all the classes for free. So you technically could run through this one too. This one just kind of relates it to gaming, so it's kind of easier for not boring the crap out of you. Where like, I mean, you could just look at this. This looks more entertaining than this. But I was messing with the SQL, but the SQL is going like super slow. The example on a slide looks a bit weird. Oh, you talking about this one? The one that he's using right here. Yeah, because the well, he talked about that earlier. The equals and the equals. Because it was, what was it? I don't even remember exactly what it was. The equals sign was like if something was equals, but equals is like if it equaled exact or something. But I know the exclamation mark is if it doesn't equal something. So I don't actually understand the entire point between equals and equals. It's still a little confusing for me. I think equals is used more as like for like putting in a command, versus equals is like when you're trying to identify that something is actually equal to something. Like I think that's the real equal sign you're supposed to use. I think when you use it here with the X and the Y, I think what he was saying, I'm not positive on this, but I think what he was saying was you can use the equal sign a single time really as just like for coding situations, but when you're trying to determine that something is equal to something, because this is a command, that's what it is. X equals a float. You're telling it what it equals. This, you're saying if X is equal to Y. I think that's what it was.
The piece I want to remind you of is the fact that when we do comparisons, we need to use the double equal.
Yeah.
Equal sign binds a value to a variable. Here I want to compare two things, and this is a standard place. I make it all the time where you'll get a bug. Don't worry when you do it. Python's going to complain at you saying you're trying to do a binding in a place that you can't. But remember, this is a place where when I'm doing a comparison, I want to use the double equal sign in order to make the comparison of two values and return a Boolean.
Yeah, that's what it was. Yeah, so the first equals is you're telling it, you're giving it a command, you're telling it that something's equal to something. The other one is used, like you can use the greater symbol and the lesser symbol to, basically ask it if this is greater than this. That's if this is equal to this. You're not telling it that it is. But
what have we added? First simple kind of program. Branching programs allow us to make choices and do different things. But it's still the case that at most, each statement gets executed once. I might skip a set of statements if I skip over that branch because I don't get there. But as a consequence of this, these are what we would call linear programs. They run in constant time because I execute each instruction at most once. And the maximum time to run the program is going to depend only on the number of instructions that I have there. Still valuable to make some decisions, but it's not going to give us the power that we want to really build interesting algorithms, and that we're going to get to next time.
I hope this stuff picks up a little faster, because this feels like really slow for me. Okay. What does it just want me to... Oh, it wants me to say what it's gonna say for these, so let's go ahead and clear that off. Okay, so 3. Well, I mean, I think 3 over 4, it's going to give me a Boolean operation, and it's going to tell me that it's false because 3 is not greater than 4. Yep, okay. That's what I figured. And then in this situation, no, it's going to be false. Oh, wait, no, that's true. That's true. My bad. I wasn't reading. False. pretty sure. 2 plus 2 is equal to 4. I feel like it's going to say that that's true. It might not. Because if it's not, I mean, I feel like that's going to say it's true. Okay, true or false. What the... What? I don't know what that would say. Let's see. We get, yeah, it just gives an error. Okay. False or false? Not false. I feel like that's just gonna give it an error. Oh my god, what the fuck? Oh my god. What is this? Okay, look, I'm gonna type false or false. It's gonna give an error, yeah. Not false is also gonna give it an error. Yeah. And okay, let's try this one. 3.0 take away. Oh, put 3 again. 1.0 is not greater than 5.0. Take away 3.0. Why so many decimals? False. Okay. Okay. 3 or and oh my god. This is gonna be interesting. The or function. But what is it gonna do if I put or? 4 over 5 or what? Dude, I don't know. I feel like that's gonna give me an error. 5 or 3 over 3 under 4 and
Their clothes and their toys and their everything get in here.
the kids.
Yes. Been picking up the toys all around the house.
Olivia, probably. I'm sure she's the only one that would do something like that. False. It says that that's false. That ain't give an error. So what does it do then? Does it take this? Hold on. 3 greater than 4. That's false. But what is... Okay, 2 is less than 3. And 9 greater than 10 is false. So it just says false. So if you put and, it's false. If you put or, it's true. So this carried the false from here, and gave it both false because there's only one that's true and it's 2, 3. But when you put and, it combines that boolean. If you put or, then it picks that there's one of them is true. Okay, this is interesting. This works kind of wild. Okay. So 3 greater than 4. That's false. Wait, did I already do that one? Yeah, it's one of the parentheses. That's false because it does the or and the. Okay. Alright, so 4 greater than 5 is false. or 3 less than 4 and 9 greater than 8. That'll be true. Okay, not. What is not gonna do? Yeah, I don't know what that's gonna do. Okay. Let's do not. Let's see, 4 over 3 and 100 over 6. Wonder if I can guess what this is. I don't. Okay, so 4 greater than 3 is true, and 100 greater than 6 is true. What does not do to true? It turns it false. Because it's like, what is it, like saying psych? Like you're like, hey, this is true, but then you tell it not, so then it's like psych back the other way. False.
In case you're wondering what he's looking at, he's giving me the same look he gives me when he asks me a question and I don't know the answer, or I say something and he's like, what do you mean? That's the look he gave me. Because I don't know. I don't know what to tell you.
Mm-mm.
May the fates be on your side.
May the fates be on my side. Oh my god. I thought you were leaving. Are you still leaving?
What time is it?
I don't know. 3:46.
I still got 15 minutes. I'm just tidying up here and there. Just try not to let the house escape, which it's already done, but whatever.
Well, he did talk about that. The equal. I mean, that's that last part that I was reading earlier. I just saw your comment about that. But yeah, he was like literally getting to the explanation of the equals when I paused it and then played it. But yeah. I guess not. Well, I guess he was in the middle of discussing it. He was trying to get to that part, and I had the video paused. It's been about 5 hours. 4 hours and 37 minutes now, actually. Well, the SQL thing didn't last that long, so I wanted to do something else, and honestly, the SQL was kind of boring me. It wasn't bad. It was starting to pick up a little bit. Then by the time it started picking up and kind of entertaining me, then like I reached the end of the little free trial. And so, yeah, then I started messing with this. I hope this stuff's going to start picking up a little bit more than this, but... So, and if something's false, though, and you put nots, does that make it true? Not... over 4. Oh, hell. Yeah, so not just reverses things. Well, essentially, true is 1. Yeah, I know that. Or is plus, and is times. Not flips it, so 0 becomes 1, 1 becomes 0. What? But not is, yeah, not flips it. Yeah, that's what I was thinking. Is times. Yeah, I noticed that with or, every time you use or. Well, every time I use or in like a Boolean, then whatever is true is what it takes. So I guess if you give it a command and it's true, then it gives it a 1. And if you give it a or, then 0 plus 1 is 0. But if you put and, oh, that's what you were saying, and is times and, because and, if you had a 0 and a 1, then it would be 0, which would be false. That makes a lot of sense. Yeah, that's what I was picking up. I didn't even think about that, though. Like, the and would be times, the or would be plus, and the nots, well, yeah, it just flips it, but... Oh, if you're using like the command for true, you have to put a capital. I don't know. Yeah. Yeah, you're right. Yeah, I noticed that it's like that with some of them. Like, I think the none. Yeah, none's like that too. Very specific on the commands. I heard Python's like the most forgiving one of the other kind of coding things. Oh yeah, so this is false. No, I got all of them wrong. What'd I do? Oh crap. Okay, for each of the following express. Oh, it's because I'm not putting capitals on here. Are you saying? Oh my god. Of course, it would be because of that. Oh my god. Oh my god, I didn't even notice that. Yeah, I mean, it's trying to train you to start using your capitals because you have to use them. I think error is just, yeah, it's just fine like that. Okay. Yeah, because the command won't take, so they're making sure you put the correct commands in there. Oh wait, error doesn't do it with a, hold on, I thought it just said you could put error like that. Write the word error. Okay. Evaluation will lead to an error. Write the word error. Note this is a word, not a string. No quotes. Does it want me to put capital error? No. 4 is greater than. Oh, wait. It's not taking over those. Oh, now I'm confused. Okay. Some of these, I was just trying to come up with my own answers, but obviously that didn't work. 4 greater than. I mean, that. How is that false? I mean, I guess, but like, I guess to a computer they're not equal. Okay.
Alright. Where's my phone? Alright, babe. I'm gonna go pick up Sativa. Love you.
Love you too. Okay, let's try. False. True or false? True. The or. Okay, so true or false. Man, I thought that was gonna get. Okay, wow, this tripped me out because the one, and the or is plus. Okay, okay. Oh, this is a trip. Okay, and then if it's or, it's gonna be false. Oh my god, this is the ones and zeros thing is a trip. Not false flip, so that'd be a 1, so that'd be true. Oh my god, this is wild. This is kind of interesting. Dang, that was a trip. Okay, I learned something that time. All right, exercise 9. Let's see. Below is a transcript of a session with Python shell. For each expression being evaluated, please type and the value.
What do you think, babe?
Huh?
Is this a vibe?
What? What? That's something.
That look weird?
You look like you're trying to.
Trying? Awesome.
I'm trying to be young again.
Trying to be young again. This is my vibe. Fuck.
Oh, sorry.
Oh my god.
Fucking with you. No, you look cool.
I see how it is. I'm getting ready for my date. Excuse me. Somebody needs to take me on a date. Guess I'll get one today. favorite? You fell? Do you need to kiss it? Oh, there she goes. Can you call my phone?
You
Can't.
said you were leaving like so many
I
times.
know, but I can't leave without my phone because I need to tell Sativa I'm there. She's not gonna come outside.
Well,
Bro, I would have never found it.
nope.
Alright, love you.
Definitely not. Love you.
See you later, sweet cheeks.
Mm.
Oh my god.
Mm.
We'll see if we can make chocolate boxes.
A equals 3. A equal to 5.0. And then A. What is that gonna do? Below's dresses. If evaluating an expression would cause an error, select none type and write the word error. Okay. While you could simply type these expressions into your, we encourage you to answer them directly since this will help reinforce your understanding. Okay. So it wants me to try to figure it out on my own before checking it. Assume that the expressions are evaluated in the order shown. Okay, so if you say A equals 3, and then you're like A is equal to 5, it's going to say false. And then you type A. Is A going to... I mean, A is still going to equal 3, right? Or is it going to equal false? Well, you're just asking it to... I'm pretty sure it's still going to equal... I think it's still going to be an integer, and it's still going to be 3. 2, B equals 10. C equals B is greater than 9. That's true. So C equals Boolean true. Oh man, I'm a genius. I didn't even have to do it. Okay. Well, for each of the following expressions. Okay. 3 plus 5. That's going to turn it into a float. And it's going to be an 8.0. I'm pretty sure. 5 divided by 2 is probably going to turn it into a float. And then it's going to be, I don't know, 5 divided by 2 is 2.5. Okay, 5 divided by 2 is equal to 5 divided by 2.0. Oof. Well, you know, that one's interesting. Because it's going to be a Boolean. And it should be true if it calculates those. No, it won't be. It'll be false. Because, yeah, it's going to be false. It's going to be false. Watch. Okay. 5 divided by 2 is going to be a float. And it's going to be 2.5. Round 2.6 is going to probably turn into an integer at 2. Well, if it rounds it off, I would think it's going to round it. But I don't know. I know if you turn it into an integer, it goes by 2, but I don't know if you put round, if it actually rounds it. Okay. Integer 2.6 is going to put in an integer and put it at 2. 2 plus 5 float is going to be 8.0. 5 times 2 is 10. 5 times 2 is also 10.0. Is it equal? No. So it should be false. Let's see what I got. Oh! I got a few wrong. Okay. Let's see what I did. Oh, so if there's an equation, then if there's an equation, it does the equation first, but does it... See, that was right. That still keeps it as a float. But it recognizes that floats... But it doesn't recognize that a float and an integer are equal, right? Wait, I got this one wrong. 5, 6... Oh, that's a 2, not a 3. God dang it. Whatever. 5 times 2. Yeah. I mean... But I thought if you put an integer like 5, 5.0, it'll put... Oh, it will put true. Oh, that was that plus thing for... Oh, that's why that was false. That wasn't equal. Man, I'm not paying attention. Okay, whatever. Oh, cancel. Okay, well, I messed up there. So it recognizes that integers and floats are the same. Okay. Ah. Okay, in this lab, we will look at different conditional flows and try to gain an intuitive understanding of how conditions work. Imagine you are trying to leave your house at 10 a.m. tomorrow. Depending on what you have to do in the morning, figure out what time you should set your alarm for. Select different responses to the questions below. As you select different responses, notice how the flow chart on the right, same time the changes. What time do you need to wake up? Do you hit the snooze when your alarm goes off? Do you need to shower in the morning? Oh, it's adding and taking away the time that it takes to do that by using the booleans of yes and no. I see what you're doing. Okay, cool. How many snacks do you have to pack? And then it adds minutes for all these snacks. Yeah. Was this lab? Yeah, it was cool. It's whatever. Was this lab entry? Yeah. Lab interactive? Yeah. Is lab easy to understand? Yeah. Help you by drawing. Yeah. Helpful. Yeah, it was helpful. Will you use this lab when studying for exams? Ah, maybe. I don't know. What? Oh, God. There are right and wrong answers? What is this? What? I have to put neutral for everything? Man, ignore incorrect feedback? What is this? What? Neutral, maybe. I don't understand. Ignore incorrect feedback. Oh. Oh, well. I already put it. Screw it. You're bored? Oh, yeah. Well. We could play a game real quick. You said you're already on, right? I'll just switch it over. Variable binding. Right hand side value, store it. Okay.
Welcome back to 600, Part 1. In the first lecture, we started talking about computation, computational thinking, and we began to introduce simple expressions and very simple programs. In this lecture, we're going to add a new type. We're going to go back and look at branching as a key element in order to make decisions in algorithms. And then we're going to start introducing the first class of algorithms that are going to be really valuable, things called iteration or iterative algorithms. To do that, I want to just quickly remind you of things that you saw last time and that you need to keep in mind. First of all, variables, often called bindings. These were names that we had to which we could associate values. And we saw they were created by using a name, followed by an equal sign, followed by an expression that had a value. Why did we want the name? It could be descriptive. It tells us what that value is. It gives us something that helps us think about how we're going to use that. It lets us reread code more easily, and it certainly can be meaningful because it gives us a sense of how we want to use computations in more complicated ways. One of the things to remind you is there are certain words that cannot be used as variables. These are things called keywords, things like int or float. They describe a type. They cannot be used as a name for a variable. There's a set of these that we'll talk about as we go through, and you'll notice in Python when you type one of these keywords in, it'll show up in a different color, which is a hint that it's a keyword and not something you should be trying to bind as a name for a value. The value could be any legal expression that returns a value, and that's going to store information that we're going to use. And finally, we saw that we could update a value associated with a name by reassigning it using another assignment statement. The way we did it, just to remind you, was we compute the right-hand side of the expression. For example, here, the value associated with 2 is just the int 2. We then store it, sometimes we refer to that as bind it, to the left-hand side, which is the variable name. That creates a binding off in the machine of x associated with 2. But of course, we can also replace it with a new value. And here, again, if you look at the second expression, remember, we first evaluate that expression. The value of x right now is 2, so 2 times 2 is 4. That associates the the value 4 with the variable x, which says when I get around to then evaluating x plus 1, this is going to be 5, which is the value associated with y. Equal sign does the assignment. It creates those bindings for us. And as I just said, we're going to always compute the value first and then override the name if that value is actually used, or rather, if that name is used as part of the expression to get the value. You might think this is pretty straightforward, but we need to be careful about the order in which things are done. Suppose I've got two variables named x and y, and I want to swap their values. The little sequence of expressions here looks like it should do the right thing, right? Wrong. Let's think about it. The first expression assigns x the value 1. The second expression assigns y the value 2. The third expression gets the value of x, which is 1, and assigns it to y. So I have x is 1, I have y is 2. I look up the value of x, I now assign it to y, so the 2 is replaced by 1. Oh, now when I do this expression, it says, what's the value of y? It's 1, assign it to x, and I replace the 1 with a 1. So it didn't swap them because there's a sequence to this operation. Okay? It doesn't do what you think it was going to do. There's a better way to do it, in fact, the right way to do it.
Hello? Yeah. Oh, I can take a break. Oh, you just want to talk or what? Oh. Oh. I don't know. Oh. Well. Well. Well, I finally started typing stuff, and then it started getting actually interesting.
which is to temporarily assign the value of y to the variable temp so that I can overwrite the value of y, and I still got that value around to restore in to x. So we need to think carefully about not only what do I compute as a value, and what do I give as a name, but the order in which I do it, because if I lose a binding for a name, I can't get it back. But that reminds us then of how to do assignments, how to do bindings, and how to do the actual sequence of operations to create bindings associated with variables. So far, we've just been playing with numbers. Names for numbers, but basically just with numbers.
Oh, yeah, no
Now we
stress.
want to add in one more type of object. We've seen ints, we've seen floats, we've seen bools, which are ways of getting values back out of tests. The last thing, or the next thing rather, we're going to add in is a string. We'll see a few others as we go along, but strings are going to be valuable to us. And what's a string? A string is simply a sequence of characters. Letters, special characters, could be spaces, could actually be sequences of characters put together into words, put together into sentences. And those are all contained within either double quotation marks or single quotes. Let me show you some examples. I've got some on my slide, but let me show you some examples with my screen. I can give the name hi to the string HELLO space THERE double quote. Those quotes on either end say, treat this entire sequence as literally a sequence of characters. And if I ask for the value of hi, it prints it back out. In this case, with a single quote around it. As we said, we can either use double quotes or single quotes. Why? Partly historical. One would really work, but a place where double quotes are handy is if I actually want to use an apostrophe somewhere in a string. Because from Python's perspective, the apostrophe looks like an end of a quote. And so, for example, if I want to say, foo is, this isn't, right? Notice that the single quote does not get interpreted as the end of a quote, and I can put out the value of foo. Once I've got strings, I can put them together. So, for example, I could say, I'm going to give name the value Eric. I could certainly print out name. What's its value? There it is. But I could also put things together. And the next expression looks a little unusual. Greet is hi plus name. And when I print out greet,
Nope, typed it wrong.
sorry, if I type properly, it would help. Print out greet. It puts the two things together. Hi there, and Eric. Two things going on here. The first one is, whoa, a little funky to think about adding strings together. But just as we can add numbers together, strings have a natural way of getting combined. In this case, it's to concatenate them together. To literally take the first string, glue the second string onto the end, that creates a new string, and I can print it out. But if you look at my computer monitor, it didn't quite do what I wanted. It said, hello, Theric. I have no idea who Theric is. I'd really like to have it say, hello there, Eric. And so I can get that by adding in a little blank space. And so if I type in greeting as hi plus a space plus name, then the value of greeting is what I wanted. Hello there, Eric. Really nice. Notice, concatenation, just as with numbers, could have multiple things in a row. So I can concatenate multiple things together as I did here. What we say when we talk about using addition this way, by the way, is we say we have overloaded it. We have had addition apply not only to numbers, but now to strings. Oh yeah, we talked about that earlier on. Remember when I said in the first lecture that the type of an argument, the type of an object, would tell an operation some important information. Here it does that because it's telling addition. If the two things are strings, concatenate them. It's also telling addition if I give you two numbers, just add them together using straightforward arithmetic. So I can use addition in multiple places to let the type of the object define what's going to happen. Once I have strings, I need operations on them. We've already seen the first one. We can do concatenation. But we can do some other things with strings. In particular, we can do successive concatenation. So if I type 3 times the string Eric, I get an echo. 3 versions of Eric are stitched together. So I can successively concatenate things together. It's kind of nice. And again, notice I'm overloading multiplication here. I'm saying multiplication of a number times a string is simply saying give me 3 versions or n versions, however many versions of that string put together. I can ask for the length of a string. And that makes sense. It tells me how many characters there are in that string. And that will include, by the way, counting spaces. So the length of hi there includes the space, not just the characters. It tells me how many literal elements there are inside of it. Strings have things inside of them. They're the first version of a non-scalar object in that I can get out pieces. And one of the ways I can do it is say I can index into it. So if I take the string Eric and I want to get out the first element in square brackets, I can say give me the first element, and it gives me R. Wait a minute. That's not the first element. The first element's E. In Python, we have chosen to decide to start counting starting at 0. So if I want to get the 0th element of Eric, I would say, give me the 0th element. And there it is. I've already bound name to be Eric. So notice, by the way, I could ask for the 0th element of name, and it gives me the 0th element of the value associated with name, which pulls back out the E, exactly what I wanted. If I try and index beyond the length -1 of a string, I'm going to get an error. And that's because I start at 0. So even though this is of length 4, if I take the string Eric and I ask what's the 4th element, it gives me an error, something called an index error that says you tried to go too far outside of it. One last thing about strings. I can certainly get a single element out. I might want to get a chunk out of it. And so I can slice a string apart by giving it a somewhat funky looking expression. I take Eric, and again, in those square braces, I give it a starting point, which is 1, and a colon, and then an ending point, in this case 3, and it gives me the first and second elements of the string, R and I. I can choose to say everything starting at the beginning. I could use that as a 0, but I can also do that by saying give Eric with nothing before the colon and just 3. And it gives me all the elements up to, but not including the element number 3.
Oh, so
I give it
weird.
a starting point, a string. I'm going to get an error. So the length of hi there includes the space, not just the characters. It tells me how many literal elements there are inside of it. Strings have things inside of them. They're the first version of a non-scalar object in that I can get out pieces. And one of the ways I can do it is say I can index into it. So if I take the string Eric and I want to get out the first element in square brackets, I can say give me the first element, and it gives me R. Wait a minute. That's not the first element. The first element's E. In Python, we have chosen to decide to start counting starting at 0. So if I want to get the 0th element of Eric, I would say, give me the 0th element. And there it is. I've already bound name to be Eric. So notice, by the way, I could ask for the 0th element of name, and it gives me the 0th element of the value associated with name, which pulls back out the E, exactly what I wanted.
His name equals Eric.
If I try and index beyond the length -1 of a string, I'm going to get an error. And that's because I start at 0. So even though this is of length 4, if I take the string Eric and I ask what's the 4th element, it gives me an error, something called an index
she
error
already
that
left.
says
She left. Oh, yeah.
Oh, Dada,
What?
is there a way you could put this tattoo on me?
The heart?
Yeah.
Oh. Do you have to do it right now? Can you wait?
No.
I'm not the tattoo artist.
But you're
But Mommy always does the tattoos.
She always does it. Why not you have a ton?
Because she's the tattoo artist. I don't want to steal her glory.
At least just do this, put this in it.
Okay, if you get me in trouble and hurt her feelings, I'm gonna say it's your fault.
Do it.
Oh my god, where do you want it?
I want it to right here.
Okay. Hold on, come here. It's not gonna last that long when I put it on.
I know.
Because I don't know how she puts it on differently. I don't know.
Not gonna last as long. It's not gonna last so long.
She does it a certain way where it lasts longer or something. I don't know. She just does it a better way. Where do you want it?
Wait.
Just leave it on there for a while.
Like how long?
A long time. Till it dries. Wait.
What?
I don't remember. Do you have to leave it on there until it dries? Or maybe I just gotta pull it off. I don't remember. Oh, there it is. Okay, never mind. I don't know what I'm talking about.
Dada put a tattoo on me.
Ugh. Ugh. Yeah. So if you don't play a match of Rocket League, we play a little match. How much do I got left? I got one more minute. One more minute of this.
You tried to go too far outside of it. One last thing about strings. I can certainly get a single element out. I might want to get a chunk out of it. And so I can slice a string apart by giving it a somewhat funky looking expression. I take Eric